Good morning, everybody. Can you hear me?
Good morning, sir. You are audible.
Yes, sir. Good morning. You are
Thanks,
audible.
Ashwin. Thank you.
Good morning, sir.
Mr. So good.
Good morning, sir.
So,
Good morning, sir.
screen is visible. Good.
Yes, screen is visible.
Excellent. Excellent. So, we have 18 candidates up to now. So, let's wait a couple of minutes more if somebody is still joining. So, anybody who can summarize what we did yesterday so that we can start fresh. Any major topics which were covered yesterday? We will just highlight what was done yesterday. Any volunteer? We did some intro, some conceptual things on MEC. That's HCU, hydraulic control units.
Yes, sir. Yesterday we did a HCU hydraulic control unit. How to test accumulator pressure.
Excellent, Sampath. What else?
Yeah. Um, that's all, sir.
Good.
Yeah,
Excellent.
Feedbacks about HCU unit, like that. We covered some topics.
Okay. So today we will basically focus on hydraulic power supply unit, HPS we call it. But in case you have any doubt for yesterday's session, any small doubt, you can open up now and let's clear it. Otherwise, I will start with my topic. My name is Harinder, Assistant Manager with the LNG DFT team. And I will be taking your first 2 hours for hydraulic power supply units. But in case you have any doubt regarding MEC, any conceptual doubt, or you have seen something in your previous ships and that was not clear what chief engineer or first engineer did, or what office email came, you could not understand what was the background behind that, we can take it as a case study, we can discuss, we can elaborate. That will help other candidates also to get more conceptual clearance. Otherwise, during these 2 hours, I will discuss, first of all, okay, let's then formally start. Then we can discuss, we can keep on discussing this. Okay. So today, as I said, HPS unit we will do. And in this HPS, we will do system layout. I will start with system layout. Then we will focus our attention to filter and servo oil. So we will spend some time on filter and servo oil, because that is one thing which is most affected by operator. By operator, I mean of us engineers. Startup pumps, we should know operation, we should know the logic, how it works, but more or less, this maintenance part is not so much regular. But the upkeep of filtration and the upkeep of servo oil for efficient main engine performance is very important, and that is in the hand of us as operators. As engineers working on board with MEC, we should be very much clear about the importance of filtration and the quality of servo oil. Okay, so we will spend some time there. Then we will see startup pumps, engine-driven pumps, valve block, and then finally small touch-up on electric-driven pumps. In our all EPS new building, we have engine-driven pumps, but few years back, we had some second-hand deliveries, big container ships. They had electric-driven pumps, but only 3 to 4 ships. Remaining all are with engine-driven pumps. But I will try to just touch up on that, time permitting, because time is not so much luxury here today. So if we have time, we will touch that. Okay, so that will be our agenda. Okay, so if no further doubts, if nothing to discuss from yesterday, we will start our day. Okay, so this is our basic PID. Okay, basic PID for our HPS system. Okay, so the servo oil is something which is developed from our main engine system. Okay, so you might have heard this term since yesterday, that MEC basic is the use of servo oil by advanced electronic automation to activate various components. So the working medium is servo oil. So servo oil, by servo oil means the better quality of our lubricating, okay, which is then becomes our operating oil. So let's trace our lines. Okay. So from sump, which is like our main engine sump, okay, we will have our main lubricating oil pumps, okay, main lube oil pumps. So they will supply oil, let's say in the pressure range 2.4 to 2.5 bar, can be little more depending upon the system layout. Okay, so let's say we have main lubricating oil pump supplying pressure at this T junction. Okay. So this T junction then divides oil to piston cooling and bearings. So all the main engine requirement of oil is done towards your left side. So if you are working on a MC engine, which is conventional MAN 2-stroke or MCC, this will be only line which is available. Pump and go left, and nothing goes this side because it is not an electronically controlled engine, MC and MCC. But in ME, you have a branching which diverts the oil towards your fine auto filter. So you will have a fine auto filter, okay, and this fine auto filter then provides oil to the suction of your electric driven hydraulic pumps and your engine driven hydraulic pumps. Okay, so same 2.5 bar oil is then converted to your servo oil. Yeah. So same 2.5 bar oil is then converted to your high pressure hydraulic. When it is standstill, when main engine is standstill, electric driven pumps are used. Okay, and when main engine is running, your engine driven pumps are used. That time, when engine is running, electric driven pumps are stopped, and your engine driven pumps takes up the load and provides this oil to your HCU unit. Okay, now as the engine developed, MAN developed its engine. So you might have noticed this yesterday, that this engine was developed, let's say 20 years back. Commercially, it was available 20 years back. And initially, when it came as a 200 bar system. Okay, but later, after a few years of more refinement and more R&D, this engine MN started providing as a 300 bar system. So why they changed this one? because if you have a higher pressure rating, the size of these pumps becomes small from a bigger 355 cc. Yeah, let's see. Yeah, from bigger 355 cc, it became to 250 cc. Okay, and also you can see that the requirement of pumps also reduced. Same pipe and hose dimensions, because the relation between flow and pressure shown by the equation down is not so much relevant to us. But the point here is, when you work on ME, you should be aware that whether it is a 200 bar system or it is a 300 bar system. The benchmark is like all the latest engines, let's say delivered 10 years back, are all 300 bar. And before that, most probably you will get a 200 bar system. What is the difference between them? Mechanical. If you see here, yep, the oil provided to your SCU is passing from one SCU to another. So same HPS oil in 200 bar system is provided from one SCU unit to another SCU unit. It is a double walled pipe and it goes like this. But if it is a 300 bar system, the oil will be provided underneath of HCU independently to each SCU unit. Okay. So later in the day, I will show you some photos where you can see that the oil is led not like this, but here you will have safety block, and from safety block, it is independently led to your units. So why this information is important? Because when you are working on 300 bar system, the amount of hydraulic hoses increases. Okay. So you should be aware that you are on a 300 bar system. It employs more high pressure hydraulic hoses. You should maintain proper inventory of these hoses. And when it is required to change as per PMS, you have to change all the hoses. Okay. And keep spare one set available with you. Okay. So that is the point, that when you are working on 200 bar to 300 bar system, you should be aware that this will be the difference in this one. Okay. Okay. So we have done this one. So this will be your first visual of MOP screen. So your HPS is having a dedicated MOP screen. So we can trace this starting from left, that this is the universal sign of filter. Okay, we will discuss this in detail. Okay, then you have your suction pressure gauges and your engine driven pumps. Okay, engine driven pumps. Then you have your electric driven pumps. Okay. These electric driven pumps then provide oil to your P2 line. Okay, and your engine driven pumps provide oil to P1 line. Both the lines are interconnected by means of non-return valve plus a mechanical valve. We will confirm this little later, but if I remember, this valve number is 316. Okay, so we will confirm it little later when we discuss PID. But you should be aware that this valve is normally closed, and we open this valve only when we are testing this depressurizing valve or safety valve as per PRS. Okay. So going back, your suction line, your electric driven pumps, okay, then your P1, P2 line, and then it goes to your each SCU unit. Okay. while it is going, it is also measuring how much is the pressure provided. And this is the set point. The set point provided by your main engine ECS, engine control system. So this is the set point which main engine control system thinks is sufficient for running of engine. So this set point is dependent on what? This is load dependent. Okay, we will see that as you increase your RPM from dead slow to slow, half, full, so this also proportionately increases. This set point also increases. And if you are on Maggie or a DF engine, you will see the moment you change your engine on gas, okay, the supply of oil requirement also increases. The set point increases a bit more. Okay, so set point is dependent on the load requirement. Okay, so this keeps gradually increasing as your load demand on engine increases. Okay, so this is the basic of your MOP. Remaining these valves, relief valves, okay, the safety valves, non-return valves, we will discuss when we discuss our PID in detail. Okay, so I just want to highlight there will be few items which we introduce in first phase. Then same items will be reintroduced after some time in more details. Okay, so we will touch same topic gradually and increase the explanation. Okay. Okay. So this is your HPS screen. So let's now see the little theory part into this one. So hydraulic power supply unit, the function of HPS unit is to deliver the required high pressure hydraulic oil flow to the fuel injection system. We can call it as a HCU because it also utilizes or supplies oil to your cylinder lubricators. Okay, it gives oil to your gas block where you will have activation of various gas components basis the supply of HPS oil only. Okay, so the valve actuation when the engine is either at standby or running. So this both phases require HPS oil. So the oil is provided either by electric driven pumps or by your engine driven pumps, depending upon the state of your main engine. Okay. So this is clear. This was our basic idea of HPS. Now let's focus our attention to filters. Okay. Filtering unit, we have seen in our EPS different filtering unit, but all approved by Everlance. Depending upon project to project, like on our DF bulk and initial DF container mega ships, we had mostly Kangwa HPS filters, but in our latest LGIP and even our latest PCTC, we have a ball and Kirch. Okay, so all of them are approved by Everlance to be installed as a filtration unit for HPS. But this fact that they are different makers. Okay. So accordingly, as an operator, you should be aware that how to carry out maintenance on this filtering unit and what are the operating parameters of this filtration unit, because the aim of the filtering unit is to keep cleanliness level of the main engine system at a minimum of ISO 4406. So this I will explain little later. It is recommended to make oil samples and have them checked. So I think every 3 monthly. We are offloading our HPS oil samples for laboratory analysis. Filtering unit is designed with a differential pressure indicator. So all of them are provided by differential pressure alarm unit. Plus, it has got a timer where it carries out its auto backwash function. Depending upon maker to maker, okay, like Kangwa, they have a option of manual HPS filter, okay, with candles, where you can use it when required. And on the other hand, ball and Kutch, they don't have this option. They have only emergency filtration chamber, which can be used. So more on this data later. I will try to explain you both the designs which are popular in EPS and how to go about it. Okay, so let's first of all see the criteria of our ISO testing. Okay. So this is a reporting standard for fluid cleanliness. According to this standard, a code number is assigned to particle count values derived at 3 different micron levels. 4 micron, greater than 6, and greater than 14. So accordingly, you can see 4, 6, and 14 micron, okay, size, and then you will see how it is graded. So 3 number format, 18, 16, 13, where 18 represent the range code present or particle that are 4 micron and larger. 16 is for 6 micron and 13 is for 14 micron. Okay. So as a senior engineer, we have to take it very seriously that what are the analysis report of our lubricating oil or HPS. Why I say so? Because we have seen this in past that if attention is not paid, our equipments fail way too early. And one of the components which fail early are the pilot spools, okay, which are employed in our FIVA, LFI, and even on our HPS engine-driven pumps. So if the filtration or the quality of our oil is not maintained, this will be our situation in a short period of time. The pilot spool in the pilot valve suffers rather high wear during short running hours. This results in early wear out and eventually an excessive leakage amount. Okay, so just imagine that oil was not maintained properly, and then you are heading towards dry dock or a major component overhaul, and suddenly you discover that all your 6 spools are out of tolerance value. Now these things are not available on shelf because there are many models of engines and many models of these spools. So then it can cause excessive delays, but you are still in dock. But let's say you are out at sea and then you start to face these problems, which happened recently on one of our fleet vessels, that because of not properly maintained oil during voyage, they started having problems and they consumed all their spares. So that's why I picked up this topic of oil quality and filtration first, that because this is operator where us engineer can contribute a lot, or we are expected to pay more attention. On your right side, this is the sandwich filter. Those of you who have attended gas trials, sea trials, okay, they might have observed that this is a special filter, sandwich filter, which is fixed in between your LFI, ELVA, as well as on your HPS pump spools. So they are recommended by MAN engine maker that these filters should be installed during gas trial and sea trials so that your spools are protected, so that your hydraulic components are protected, because initially at new building stage, the lines might have some dirt or some accumulations, sh which should be stopped before they enter your pilot spools or main spools. Okay, so the additional safety which is provided is this sandwich filter. So in case you are attending trials, pay attention. You will definitely see these red color filters there. So I think we have stressed enough on the quality or the importance of quality of oil. Later, I will discuss and share with you one decay test Excel sheet which you are supposed to maintain, where we can see the performance of our spools, of our wells, okay, and which you should maintain so that you know what is the performance of your independent components. Okay. Any doubts so far, gentlemen? Okay. So going further, so let's see the hydraulic filters. So main filter and SFF filter. Okay. SFF fine filter and main filter. You can see the specifications are beta 6, beta 14. Okay. So now if you see like normal filter where it is mentioned, okay, 10 micron filter, 50 micron filter, this, but these HPS filter, which are working in servo oil, they are always mentioned in terms of beta ratio. Okay. If you see beta 6, this means 17 by 10. So if 17 particles of 6 micron are at the input, output will have only 10 micron, 10 particles. If particle size 14 are at the inlet 33, okay, if there are 33 14 micron particles at the inlet, outlet of that filter or the efficiency of main filter is to pass only 10 particles of 14. Okay, so this is the main filter specification. Similarly, the SFF filter, which we use in initial running after new deliveries, in case of your Kangwa built models, it is required that we use first 500 hours on SFF filter. So what is the ratio? You can see considerably high. So if there is 10 6 micron particle, only one will pass. If there are 100 14 micron particle, only one will pass. So SFF filters are very effective. Okay, but the requirement by MAN is only this much. So we use this SFF during initial running of engines and delivery, and when we have oil which is not as per specification, if we have some more particle size in our test reports, then also we run SFF. Okay. So this is a requirement based operation depending upon fleet to fleet, where where the superintendents give instructions to vessel that you run this SFF during port stay for so many hours. During running also, there is a process. You should be fully aware that you have to operate valves where the oil actually flows from SFF. Okay? Because as you can see, during port stay, your pumps are running, like your main pumps are running, but the HPS is not running. So flow will not be there. So you should have, you should follow procedure wherein you have to operate certain valves to have it flow. Okay. So this is to highlight you that these things are very important, and we are facing issues because of this. Okay, so let's summarize our understanding now with this small thing. Okay, so catastrophic failures of main engine. Because of this, what happened? Engine breakdowns had been noted in fleet vessels. Most of the failures related with FIVA, LFI, proportional valves, XPS, proportional valves. Failure of lubricator, solenoid valves stuck. All the failures point out to poor hydraulic work. Okay, so this is us as operator. We have to uh, watch this and also report it in time and do a corrective action. So what are the reasons? Grit and dust contamination during new building stage. And then you have leakage through stuffing box. If stuffing box are not properly overhauled, we all know this, but now this is a documented item. So these are the common causes. Leakage through umbrella seals of fuel booster, leakage through exhaust valve seals, water ingress through crankcase diaphragms, leaking engine components, aging and normal wear tear of hydraulic and main engine components resulting in high particle count, poor sampling procedures resulting in wrong reading. So this is also one of the common reason where we don't flush the system properly, don't take proper sample, and then the root cause we start to look somewhere else, whereas it was just a force. Okay. Wrong type of SF filter used, damaged SF filters and SF filter not in use. So this is also one of the common reasons. SF filter has 20,000 cleaning cycles. So if we exceed that, it is no more effective. So we should be keeping proper inventory of this one and discard them once their age is completed. Okay. Normal wear and tear items not filtered off. Okay. So consequences we can see wear down of spools, proportional valves, solenoid valves. Okay. Sticky valve spools, uncontrolled pressure, no pressure with pilot oil is supplied. Gradual wear down of FIVA, LFI spools. Sudden main engine breakdown due to sticky or worn out spools. Damage to ME parts. Of course, off hires, high repair cost, including loss of reputation, high stock of items to be maintained on board to deal with such failures. Failure of cylinder lubrication due to sticky solenoid. So if cylinder lubrication is failing, you can see how catastrophic it will be with the scuffing on main engine and with iron content increasing. Ultimately, only because of not keeping good quality oil, and then the chain reaction is to change the line. Okay. So whenever you see reports which is not as per maker recommendations, if they are in caution, okay, if they are in alert, okay, so take proper action. Okay, so what can be the action for this one? Okay, SF filter to be used regularly, flushing the system to be carried out. Okay, one set of filter to be supplied, renewed once every 20,000 flushing cycles. Arrest leakages and maintain good engine condition. So this is what, as an operator, we are expected. From office side, few things are considered. Of that, number two is more common on vessels, which is having a more problem. That is offline filtration, CC, Jensen CGS filter. We call it as a common terminology. So this is what we have to see when we are dealing with our oil quality. Okay. So any doubts so far, gentlemen? Okay. So going further, so let's conclude our filtration topic by having some visuals from different makers. So filter unit, ball and Kirch, okay, that is employed. So you can see 6 micron filter cartridge So always look for these production years and IDs to match with your PO. Then you have a very popular Kangwa model, K8 HS series, a Japanese manufacturer. So in that, SF filter can be easily employed, and plus the manipulation of valves will be required to pass the oil from SFF and back to the system. Okay, so actuator auto can be employed during your normal main engine running, and during port stay you can use SFF as per the instruction of your office, but make sure the valves are operated accordingly in port so that there is a circulation of oil on this unit. Okay, and then wall and curves, filter layout. So back flushing is initiated every 60 minutes. Differential pressure alarm 0.6. Initiation is at 0.6, and then alarm is at 0.8. Ball and curves, latest one. This was what is available on our PCTC. So the normal operation is your two main back pushing unit plus the FOT. But in case you have a issue or high differential pressure, and then this loss of pressure at the suction side, that time you can only at the discretion of chief engineer can operate an emergency valve. Then 25 micron filter will be in use, but this is only for the discretion of chief engineer. If we see that there is an imminent pressure drop and you will have problem with your suction pressure for your hydraulic pumps. Okay, so this was our oil quality and filtration unit. Okay, so any doubts so far regarding what we discussed? Okay, so if no doubt, now we will focus our attention to pumps, electric pumps. Okay, okay. So normally the main engine hydraulic power supply is generated by engine driven pumps, and but startup is required by our electric driven pumps. So these pumps are driven by motors, electric motors, and the capacity of this pump is designed just sufficient to start up, sufficient for the startup pressure buildup. So if you think that you can keep the engine running in case you have problem with this setup only by electric driven pumps, no, it is not possible. Okay, the engine cannot run with the engine with engine driven pumps out of order. Okay, so these pumps has to be there when your main engine is running. Electric driven pumps is only for startup, for initial starting. So they will start up and you will press prepare engine. So both pumps, master and slave, will start for initial pressure buildup. And once pressure set point, let's say 225 is reached, then one of them will stop and the other one will keep running to maintain the pressure. And as you operate the engine, let's say you are casting off, and now dead slow, you give start engine dead slow, and as the engine develops its own power close to 15% MCR, these pumps stop. And in some of the logic, there is a timer also. So whatever is earlier, they will stop. Okay. So the purpose of electric driven startup pumps is to ensure adequate hydraulic system pressure in situation where the main engine is not rotating. Let's see. Okay. So this is your hydraulic pumps, but electric driven. Okay. So the electric driven pumps are variable displacement pumps. So you can see two setups, 175 and 225. Why two? Because one is for 200 bar system and another one is for 300 bar system. Okay, so it can be either 175 or 225. Okay. So the situation where the system has been depressurized, for instance, after an engine shutdown or blackout, the electric driven pumps must run for certain period to build up an adequate system pressure for starting the engine. The length of period is determined by the accumulator capacity in the system and the flow produced by the electric driven high pressure pump. So this is in case you have any blackout or shutdown. Okay. So this is your electric driven pumps. So let's see the auto function of these ones. Master pumps running, as I said, when we start, both pumps will start, master and slave, pressure buildup, 225, okay, and then stop at finishing. So this is not. So start at engine standby condition, and when you are arriving, and once you are in port, fully make fast, and you press finish with engine, that time also it will stop. Second stop, which is important, is by a timer at a specified engine RPM, default 15% MCR, it will also stop. So during engine standby condition, when we sail out, they will start both pumps. Once you have 225 bar, one will stop, another one will keep running. And then once engine picks up RPM, it will stop by this particular logic. Okay. But when you are arriving port, okay, when you are arriving port and you are stopping, maneuvering, when RPM is 0, then you are brought alongside, make fast, and then these pumps keeps on running because engine driven pumps are not working that way. And when you press finish with engine, that time also they will stop. Okay. So 1 and 2, you have two pumps. So you can change over these two pumps depending upon your changeover routine. So you can make number 2 as master and number 1 as slave. Okay. So every 6 months you can change these pumps and keep 1 as master and 2 as slave. Okay. So this is your electric driven pumps. Next, let's see our engine driven pumps. So all engine driven hydraulic pumps are of variable displacement type. Okay. They are of the same size. Displacement is electronically controlled by the ECS via a control valve on the pump. The pump function when the engine is rotating, as they are mechanically driven by the gear assembly or by the sprocket chains, which is permanently connected to crankshaft. Their flow is determined by the actual displacement and rotational speed. So we can see here that unlike electric driven pumps, where motor is running at a constant RPM, these pumps, they are dependent upon engine RPM. So as the engine picks up RPM, their RPM also increases. And then the spool piece on top of this one. Okay, so this proportionate valve will control the amount of flow or the pressure generated from these pumps. Okay, so later we will discuss this in more detail. Okay, so each pump is designed to have two direction because our engines are reversible engines. Our engines move ahead and astern. So as the engine moves astern, the direction of pump also reverses, but the suction and discharge ports stays the same because they are mechanical. So suction and discharge port stays same. What changes in between is the angle of swash plate. From positive, it becomes negative. Okay. So we have an animation to explain this in detail. Later, I will show you that also. Okay. So the engine driven pumps supplies the hydraulic pressure for the engine when it is running. Okay. In the event of failure of one pump, the remaining pumps are dimensioned to be capable of supplying sufficient hydraulic oil corresponding to 66% of engine load. Okay. So that if the electric power to the pump displacement control valve is lost, the pump will mechanically go to maximum displacement in ahead direction. Okay, so this is also very important concept, that the control logic for your proportionate valve, if you have loss of control logic, this goes in 100% ahead direction. So this will provide sufficient oil flow and pressure, but only in ahead direction. Okay, so let's see the different layouts of our HPS. Okay, so on smaller bore engines, okay, so let's say in case of bore size more than 50, let's say 60, 70 bore engines, so you will have a small chain case. Okay, then this chain case will drive a gear, and then these three engine driven pumps will be mounted on the aft side. On even smaller bore engines, you have like, let's say less than 50 bore, so they are installed just on a gearbox, which is very close to your flywheel. So as the engine size grows, let's say on our mega container ships, okay, our 15,000 TEU ships, so the bore size is 90, and also on some of our engines it is 96. So in that case, the units for 90 bore is 11 unit engines. Okay, so the 11 unit engine, so the HPS is stationed or designed in between number 6 and 7 unit. So HPS is designed between number 6 and 7. So I will show you a new building photo of one of our mega container ships. So this is one of our DF container ship at the building stage. So you can see that the sprocket wheel is at the center. So number 6 unit, 7, 8, 9, 10, 11. Okay. So between 6 and 7, you have your sprocket wheel, and then there will be a chain, and on top the anti-blacher will come, and you will have your HPS thing. Okay. These mega container ships or the bigger ships, they have more oil requirement. So the number of pumps also increases. Okay. So whereas there is a, yeah, whereas we have 3 pumps here, 3 engine driven pumps. On these bigger ships we have 5. When we have 5 pumps, then the control also distributes. So you might have noticed in your control session that these pumps, they are controlled by ACU 1, 2, 3. Okay, so each ACU will control 1 pump. But if you have pump 4 and 5, then it will be controlled by ECU A, ECU B. Okay, so 4 will be controlled by ECU A, 5 will be controlled by ECU B. But also they don't have proportionate signal variable. They have binary signal. Okay, so this will be 0 to 1. They can either operate at 100% capacity or none. So when they are employed, they will be given 100% load. So they will go 100% in ahead direction. So more on this little later. Okay, so let's see a little more details of our engine driven pumps. Okay, so engine driven pumps, we can see here in more detail. So your sprocket wheel, which is connected by chain, and then it drives a gear, step up gear, hydraulic pumps. Okay, and these hydraulic pumps are now connected by means of a pump joint. So these pump joints are having a special high friction disc. all engine-driven pumps are connected to the step-up gear through the high friction disc in case pump gets damaged. Okay, and strong stress occurs in the shaft. The safety shaft breaks and protects the gear and chain. So in case you have some seizure of hydraulic pump, that it is having some issue and it is giving some resistance to rotate. So this is a sacrificial safety shaft, which is like a weak link in case the torque increases or the torque requirement is more than what it is designed for. So it snaps to save the gear, because if does not snaps and you have damage to the gears, then other pumps will also go out of use. So um, that is the point of having this safety shaft to protect your gearpiece. Okay. Any questions so far, gentlemen? So if no question, so how about a small break? Can we go for a small break?
Yes, sir.
Anybody? Okay. So we will come back, let's say after 8 minutes. Okay. Okay then. 8 minutes. Thank you.
Thank you, sir.
Gentlemen, are we back? Should we start? Hello, anybody?
Yes, sir, we can start.
Yes, thank you, Sampath. How's going, Sampath? Is it okay? You are understanding?
Yes, sir, I understand because last vessel we have this SPS system in
Okay,
dual
very
fuel,
good,
so bit
very,
understanding.
very good, very good. So I think now you have more clarity on why we need to have a good quality of oil and
Oil, yeah.
what we understand with ISO standards and the
Yes,
particle size. Okay,
yes, sir.
excellent, very good. Okay, so going further, we are discussing our, yeah. So we are discussing our mechanical part, engine driven pumps. Okay, so we just understood the importance of safety shaft, why it is required. Okay. So the next important topic in this one is your ahead and astern movement. Okay, and the swash plate condition. So the when engine runs in ahead direction and later change to astern, the piping is fixed. Okay, the ports are fixed. So the direction of oil going to outlet cannot be changed. So what solution is provided is to have a swash plate. Okay. So the pump suction port and discharge port not change because the swash plate changes angle from positive to negative. So how it happens, I will explain this in more detail by means of an animation. Okay, so let's first finish a few items more before we go to animation. Okay, here we should understand that the power available for the control of swash plate is actually provided by your pilot valves. Okay, so the pilot valves are different makers. Okay, they can be Parker, they can be Moog. So as a senior engineer, when you are checking inventory of your proportionate valves, you should be aware that the valves which you have spare is actually the valve which are provided on your main engine. Okay, so this goes with all other equipments, whether it is a HCU or whether it is a gas component valves. Okay, so the it has happened in past, and if you are not alert, it can happen with you also in future. That the spares supplied are with different maker, and sometime you don't have to panic if it is different maker. There will be a kit provided, like how these maker can be new maker valves can be accommodated in your old setup of HPS. So before you press the panic button, just make sure that you have done your homework. The new available, if they are different maker, what is the additional help provided to you, okay, to fix this in position. Okay. Okay, just to give you clarity that different makers are providing this different answer. So next is our uh, swash plate principle. So you can see as the angle of swash plate changes from positive to negative, that direction does not matter. let's say it is moving in ahead direction with the positive angle of swash plate, and when it moves in astern direction, the swash plate becomes negative. Who makes this? Your spool piece. Okay, this changes the direction, and result is your inlet and outlet stays same. Inlet and outlet stays same. Okay. So this is the basic. So let's clear our concept by means of small animations. Just 1 second, I will stop sharing this one. Okay. And try to play animation here and start sharing. Okay. Okay, let's see. I hope you have visuals. Let's start.
An axial piston pump has a number of pistons arranged in a circular array within a housing which is commonly referred to as a cylinder block, rotor or barrel. This cylinder block is driven to rotate about its axis of symmetry by an integral shaft that is, more or less, aligned with the pumping pistons, usually in parallel but not necessarily. One end of the cylinder block is flat and wears against a mating surface on a stationary valve plate. The valve plate has two semicircular ports that allow inlet and discharge of the fluid respectively. The pumping pistons protrude from the opposite end of the cylinder block. There are numerous configurations used for the exposed ends of the pistons, but in all cases they bear against a cam. In variable displacement units, the cam is movable and commonly referred to as a swash plate, yoke or hanger. The orientation of the cam, in combination with shaft rotation, provides the cam action that leads to piston reciprocation and thus pumping. The angle between a vector normal to the cam plane and the cylinder block axis of rotation, called the cam angle, is one variable that determines the displacement of the pump or the amount of fluid pumped per shaft revolution. Variable displacement units have the ability to vary the cam angle during operation, whereas fixed displacement units do not. As the cylinder block rotates, the exposed ends of the pistons are constrained to follow the surface of the cam plane. Since the cam plane is at an angle to the axis of rotation, the pistons must reciprocate axially as they precess about the cylinder block axis. During the rising portion of the piston's reciprocation cycle, the piston moves toward the valve plate. Also, during this time, the fluid trapped between the buried end of the piston and the valve plate is vented to the pump's discharge port through one of the valve plate's semicircular ports, the discharge port. As the piston moves toward the valve plate, fluid is pushed or displaced through the discharge port of the valve plate. When the piston is at the top of the reciprocation cycle, commonly referred to as top dead center or just TDC, the connection between the trapped fluid chamber and the pump's discharge port is closed. Shortly thereafter, that same chamber becomes open to the pump's inlet port. As the piston continues to precess about the cylinder block axis, it moves away from the valve plate, thereby increasing the volume of the trapped chamber. As this occurs, fluid enters the chamber from the pump's inlet to fill the void. This process continues until the piston reaches the bottom of the reciprocation cycle, commonly referred to as bottom dead center or BDC. At BDC, the connection between the pumping chamber and inlet port is closed. Shortly thereafter, the chamber becomes open to the discharge port again and the pumping cycle starts over. In a variable displacement unit, the cam angle is determining the amount of fluid pumped per shaft revolution. If the cam angle is set to 0, Corresponding to that, the swash plate is set parallel to the axis of rotation. There is no movement of the pistons in their cylinders. Thus there is no output. If the cam angle is set to maximum, the displaced pump volume and thereby the output will be maximum. If the rotation direction of the pump shaft is reversed with unchanged cam angle, then the pistons will move in the opposite directions, which will reverse their pumping action. This will lead to that the inlet and discharge ports will change place, which means that the flow direction of the pump will be reversed. Some pumps have the ability to move the swash plate over the center position. If this is done at the same time as the pump shaft rotation is reversed, then the piston movement and thereby the flow direction of the pump will remain in the original direction.
So the animation clearly said that the reversal of flow will not happen if your swash plate is changing direction. Okay. Okay, let's start. So this concept is clear now. Okay, let's go further. So hydraulic oil pressure, as I said before, depends on load and is controlled by pumps, mechanical tables 1, 2, 3. Any one pump we can select as control mode and others as other two as follow mode. So the limitation of this one is that control pump keeps the swash plate at 50% position, and follow mode swash position ranges from 10 to 100% depending upon main engine RPM. Okay, so when follow pump swash reaches to about 100%, the control mode pumps swash increases from 50 to 100%. Okay, so what this means? This means that the algorithm of control for all three pumps cannot be at the same time. So let's say you increase from half a head to full head. Suddenly, your set point now has increased from 240 bar to 245 bar or 250 bar. Okay, so set point increased from 240 bar to 250 bar. And now initial reaction of control is to the control pump. So control pump will take initial load. Okay, and then after a moment, the follow pump will pick up and control pump will come again to 50%. Okay? And follow pumps will vary their percentage contribution from 10 to 100%. So follow pump will keep giving contribution from 10 to 100%. From 10 to 100%. Okay, and the control pump at 50%. Again, let's say you are working on MCR RPM, okay, and with full gas. By gas, I means the HPS requirement will be more. Okay, in that case, if your follow pumps are already about to reach 100%, then your control pump will also start to develop more pressure or start to contribute more. So then it will also go from 50 to whatever it is required, 60, 70, 80, whatever. So it will also increase its contribution. But until the follow pumps have reached their limit, your control will stay 50%. Okay. So this is the control logic. And whenever the new load comes, the new set point comes, first one to react is control pump. And then it will shift the load to follow pumps. Okay. So this is the logic. And you can change the pumps as per your changeover routines. You can make number one pump as a control pump, 2 and 3 as follow pump, and later after 3 months you can keep number 2 as control, 1 and 3 as follow. So you can change this on NOP. I will show you this in a moment. Okay, so if scenario, if the control mode pump becomes abnormal, okay, let's say control becomes abnormal, one of the follow mode pumps changes to control mode automatically. In case of control failure of pump, the swash plate will be forced to maximum capacity ahead. Okay. So in case you have control failure, okay, you have some control failure, some MPC signals are not coming, so your proportionate, your digital output, which comes from MPC, let's say ACU1 is giving a digital output from channel 70 or something similar. Okay, so the proportionate signal which is coming from this channel is now corrupted and it's not coming. So in the absence of this signal, this swash plate will go in 100% ahead direction. So it will start to give 100% contribution. Okay, so all pumps have sensors at suction pressure, and if the pressure is too low or all sensors are failing, shutdown will be activated. Okay, so this is a clear cut. So I think more will be clear with next slide. So here we have summarized everything for you, so we can just correlate what's going on. Yes. So 3 engine-driven pumps. Number 3 is control. 1 and 2 are follow. Okay, set point 225. We are just starting. Okay, and suction pressure is 2.3, which is good. Okay, so the pressure set point, we can summarize our understanding now. Set point is depending upon engine mode. So this set point will keep on increasing as the RPM increases. Okay, the pumps have 2 running modes. We have control mode and we have follow mode. Control pump is running 50% and compensates immediately for deviation between actual pressure and set point. So as I said before, the moment you will have new set point, let's say now it is 225, the moment it will become 230 and your actual is 225, first one to react will be control. It will react first. Okay, then it will give job to follow pump. So between actual set point, over time, follow pumps will take over the compensation while the control pump goes back to 50%. So this is what I said before. In case the pressure controlling pump faces a failure, one of the other pumps will take over the pressure control. So in case you have some problem of control functioning, so one of these two will become control pump. Okay, and this will go in 100% ahead direction. Okay. Manual mode, the pressure set point is set by the operator. For testing, we can set this as we go in chief mode. We put this, press this button. We will have a manual mode, press manual mode, and then you can put the set point, whatever is required, but that is only for testing purpose. In case of control failure of pump, the swash plate will be forced to maximum capacity ahead direction. So we have discussed this before. Pump number 1 is controlled by ACU1, 2 by ACU2, and 3 by ACU3. Okay. Pump number 1, 2, 3 have their own sensor for system pressure connected to the controlling AC. Okay. Pump number 4 and 5. In case for our, let's say, mega container ships, 15,000 TEUs, big engines, 11 unit. So we have 2 additional pumps. So they are controlled by binary signal, either maximum capacity ahead or stop, and controlled by ECU A and ECU B. Okay. All pumps have sensors for suction pressure. So in case there is a problem, they will give you signal, and if all are failing, then you will have it shut. So this is your engine-driven pumps summary, which we have discussed already. So the alarm 0.7 low pressure, 0.5 is a shutdown. Sensor value deviates more than 1 bar from each other, then also there is an alarm. So this we have discussed. So let's see if I can show you this. Okay. So you can see here proportional, yeah, channel 70. Okay, proportional value set point is coming. If these milliamps are coming, is not coming properly to your pump number 3. So this is ACU 3. Okay. So if pump number 3 is not getting proper feedback, so you will have pump going in 100% ahead direction, and plus your pump will be changed from control. It will give control to other one of the other two pumps. So it will be no more as a control pump. Okay. So okay. So going forward, we will see. Yeah, this we have done already. Okay, so this is what I was trying to tell you, that we can change the control mode in chief. We can just press any one of these pump soft button in chief mode. They display as you can see, other modes also. Auto is also coming as a button. Set point is also button. This depressurizing valve is also coming as a button. So you can, as a operator, you can also change over the pumps. Okay. Next is one important thing. Okay. That is a safety feature which is inbuilt in your engine control system. So the accredited software, which is the basis of our main engine ECS, engine control system. So it will have two inbuilt safety features. So one is that the pump deviation. Okay. So what it does is that during shock test, so we have a shock test for every engine. Okay. The main engine rotation change from other pump. Okay. So during shock test, they have a data that is plotted in this manner. Okay. So during operation, so if there is any deviation from this standard curve, if there is any deviation from standard curve, you will have an alarm condition. Okay. So the model curve is generated during your shock test. Is set during shock test, and allowed deviation is plus 20%. So two types of curves we have. So first curve is that percentage load at 60% load. Okay, so you will have this much of pressure. Okay, so this is the model test curve. Okay, plus minus 20% is allowed, but if it is going more, then we need to investigate. No, that is not. So on your x-axis is load percentage, and on y-axis is hydraulic oil pressure in pound. So at any given load, it is set in your system that this should be the standard pressure, plus it has given deviation limit plus minus 20. And if it is going more, you have to see. Another one, safety, is as the RPM increases, percentage RPM on the x-axis, the total swash plate percentage is how much. Let's say the addition of all three swash plates, 1, 2, 3. So if at 60%, they are close to, let's say, 150. Okay. Let's say you are, so all are 50-50%. Okay. Control is 50, follow is 50, and your both follows are 50 and control is 50. So you are at 150. So if 60% is RPM and you are at 150 total, so you are within the limit. But if your total sum is more, then you have exceeded the upper limit, and then you will have an alarm condition and you have to investigate. Okay. So this is the system. So these type of alarms we normally see. Normally we witness this one during trials, and it is mostly issue with the scaling of limit in our accredited software. Okay. And they are solved during your fine adjustment of engine during seat valve. So let's say this is one of the experiences which I had during the curve, during the trials. So swash plate follow pump set point deviation too much from the model curve. So this was the alarm we received during one of the trials. But in that case, there was an actual problem that the proportionate valve was failing. So once you see this one, you should be able to see how much is actually the percentage of your proportionate valves which are open at that very. So normally this scenario occurs during sailing time when it is windmilling. So I hope you all understand what is windmilling. That engine is stopped, but it is still with the wave of water. It is still under movement. Okay, so that time this alarm also comes. But if it is coming only during windmilling, so then it can be ignored. It is written in your MOD. Okay, so this is one thing which we should be aware of. So if you really want to do troubleshooting, if you have a large deviation from model curve, then there are steps which are advised. Okay. So what are the moving components in this model curve? One is MPC. As I said, the channel 70, which is giving sense, which is giving a digital output, and then you have a proportionate valve, which is actually moving the swash plates, and then there is a feedback sensor which is coming from top. Okay, so these two are on pump, and then you have MPC. So depending upon your alarm condition, you can see if it is only feedback issue, then item 1 and 3, okay, sensor is issued, or your MPC point connector is issued. Okay, but if it is actual and local movement are abnormal, then item 1 and 2 can be the source. Okay, so you have to troubleshoot this one by one, all these aspects. Okay, so engine driven bypass pump, bypass valve. So this is a one important safety feature which is provided. So what we will be discussing here is this one. Okay, this valve. Now we are discussing this one. Okay, when engine room blacks out. Okay. So as we all know, during blackout, our main engine blue bulb pump is not supplied from emergency switchboard. Okay, so if your blackout happens, okay, and your standby engines, standby generators does not kicks in, and your emergency generator comes on board, so ESP will be powered, and that does not include main engine nearby pumps. So the hydraulic oil supply pump stops, leading to drop in suction side of engine driven pumps, of course. So there will be no 2.5 bar pressure available at suction. And then there are chances for the pump to run dry because engine is still moving. Okay, maybe you were running at NCRRB. Okay, so engine is still moving. Okay, the pumps, engine driven pumps are still moving. At that very moment, this valve opens. Okay, you will have 225 bar here, and this will be, let's say, close to 0. Okay, and then this valve opens and bypasses all oil to suction side. Bypasses all oil to suction side so that these pumps don't run dry and protect these pumps. Okay, so the pressure at the pump discharge is still very high of the engine revolution. At this moment, the bypass valve opens immediately. Hydraulic oil from the discharge side returns to pump suction side to protect the pumps and pipeline from damage. Okay. When the engine-driven pump discharge pressure 230 bar, the bypass valve opens to release the hydraulic pressure. When the hydraulic oil pressure side leakage occurs, the bypass valve can be opened and accessible. That is another scenario which is applicable as a reaction by watchkeeper. Okay, but normally this type of scenarios are not very common, but this scenario is common. Not common, like it can happen. It has happened with us. It can happen with anybody. So that's why the designer of engine has provided this valve, and plus I will show you later that the activation of this valve is also provided by two signals. Okay, so the designer has made it so redundant that during blackout, two signals will come to make sure that in case one signal is absent by some port, the other activates this valve. Okay, I will show you this data that how that designer has provided two signals for the operation of this depressurizing valve. Okay, so this is okay. I think this we have done already. Control failure limitations. Yeah. Okay, so let's discuss safety block. Okay, with the safety block contains pressure relief valve. So this is your HPS. So HPS will provide oil, high pressure oil, all three pumps independently to this block. So safety block will have oil. Okay, then this oil will be distributed to your HCV units. Okay, so it has to pass through safety block. So which protects the high pressure system against excessive pressure. So safety block primarily has two safety valves in that, 310 and 311. 310, as I said, will be opened during a blackout, or it will open when the system pressure reaches 310. Okay, so two functions. It opens during blackout and also it opens during high pressure in the system, like it is 310. And another one safety valve which is provided in the system is 311. That is a mechanical valve, and this will open at 315 pressure in 300 bar system and 250 in 200 bar system. So as I said repeatedly, we have two types of models in ME. One is 200 bar system, another one is 300 bar system. These 230 and 250 set points are 200 bar system, and 310 and 315 are for 300 bar system. Okay, so this is for a safety. Okay. So what else we have? The valve 310, which we discussed just now, protect the engine ribbon against too high pressure. Electrically controlled ECS can be opened in different situations to the feedback hydraulic pressure, suction side to the engine driven pumps. We have completed this one. The valve 31 is the main system pressure relief valve protecting the engine system. This valve has the highest pressure set point. So we have discussed that. The non-return valves 304 are installed oil outlet for the engine driven pumps, electric driven pumps to prevent backflow through any inactive pump. Pressure transducer 320 are used by ECS for controlling the engine driven and electric driven pumps. Okay, so this is the control block. Okay. Let's see physically what is available. So this is a physical photo from one of our ships. Okay, so you can see, okay, 310. This is your valve 310. Okay, and then you see two coils are coming. We have two coils at a time. That this valve is so important that it has to be operated in any case. So designer has provided few coils, signal will come, and then this oil will be bypassed back to the system. Okay, so 316 connection between P1 P2 line, as I said, that we will have a interconnection valves, and then this is your 311, which is the safety. So just to summarize, so you will have, this is your 310, okay, and then this is your 311, okay, and then this is your 316, and your P1 and P2. Okay, so we are here. So let's summarize and go further. Okay. Suction line, two electric driven pumps, okay, providing oil through non-return valve 304 to your P2 line. P2 line going and going towards your SU. Okay. Then you have your engine-driven pumps taking suction from same servo oil line and providing oil to P1 line. From P1 line, it is connected to your by non-return valve to your P2 line. So P2 line goes to your SU units. Here you can see that P1 line is connected to suction side by 310. So this is the valve we were talking about. Okay, the safety valve. Okay, and now this is the mechanical valve 311. The set point for 311 is, if it has to open, is 3151. Okay. The set point for this one is same 310 bar. Okay, and also it will open during blackout time. Okay, and now this is the interconnection. Normally this valve is kept shut. This valve is kept shut 316. Okay, now you have a PMS item to check this valve 310. Okay, 310 you have to check, but how you will check? You at port. This can be checked only during port stay. Okay, so you will start these pumps. You will have pressure 225 bar. 225 bar, and then you will open this to your, you will put this in manual, and then you will open this valve, but nothing will happen. Pressure will not out because you did not open 316. So I'm just stressing you with this scenario that when you are testing, you should open 316 so that you have pressure in P1 line also, and then you see the pressure indicator showing 2 to 5. Then you press opening, and then this pressure will drop, which will confirm that this valve is operating. If you don't open, nothing will go in this line, and also when you press, there is no pressure change. I hope you understand. If any doubt, I can repeat myself. Next is your manual set point, which I said that you will need to do this. This normally we do after dry docking, when we changed all our hoses and we want to check the system for any leakages. So we increase the set point and by 10% of maximum MCR, and then we check the system integrity. Okay, normally this is done by experienced engineers. Okay, so that time we need to see. Normally this is not done as a investor. Okay, so yeah, safety system bypass open. So this is just an algorithm for this too, because I said the coil can operate from ACU1 and ACU3. So this is the algorithm how it will go through channel 47. Next, in our HPS, there is one more window, that is LPS, low pressure system oil. So this is employed only in dual fuel engines. Okay, this is not any engine. Any engine part. So if you are on any ships, not Maggie or LGIP or MEGI, so you will not see this. But just that this slide is here, so we can I can explain you that there is a special pump provided in main engine system which provide pressure. Now it is a stopped condition, but normally provides 7 bar oil, and then it circulates within your hydraulic components to keep it air free, so that when pressure comes for the operation of these valves, there is no time delay. So basically to keep it the system vented, and there is no air lock in the system. Okay. Okay, so now is the accumulator. So accumulator, as I as I think Sampath mentioned that you have covered this yesterday. So nitrogen accumulators in a hydraulic system, and they are prerequisite to be maintained in a designed state that they perform their function for absorbing of any pulsation. So in our scope in HPS hydraulic power system, we have these accumulators installed on each HPS pump. Okay, to with the nitrogen filled accumulators with the diaphragm on one side separating hydraulic oil and nitrogen which is pressed down. So any pulsation will be taken care by these hydraulic accumulators. Okay. Okay. High pressure piping, as I said during the starting of this session, that we should be aware that we are on 200 bar system or 300 bar system. 300 bar systems have more hydraulic pipes. Okay, so you should maintain inventory accordingly and change as per your PMS routine. Last, what I read was every 5 years we change all hydraulic hoses, but please uh, consult your, your manuals before uh, carrying out any job. So last what I uh, read was 5 years. Drain pipe, drain pan with leak sensor. So as we can see that this HPS system is a enclosed system. So any leak from joints, from couplings, from hydraulic hoses, so they are led to this drain pipe. Okay, led to drain pipe, and then there are two sensors in this one. Okay, so two sensors like uh, high and high. Okay, so then if you have alarm, so you should like act accordingly to open safely this HPS to see if there is any leakage abnormal thing, or else if goes to high switch 1 2 3 6, it is a cancelable shutdown. So you can if you are in such a situation that this alarm came and you are in a tight navigational situation, you can cancel this and then accordingly you can take action. But my suggestion is that this we have seen before. We have seen this is not a very uncommon thing that small drops of oil can come. Okay, so we have to rectify these as it appears. Okay, and then if you don't take action during that time, and if alarm comes in an odd time, which it normally does, then you will panic. So always during watch keeping, all senior engineers inspect your HPS system, see if there is any accumulation of oil. You are not stopping oil by making a pool of rags just to stop it flow to this sensor. Take proper action, rectify, change if required some hoses so that you don't end up in a situation where you have alarm and if situation worsens up, you will have a shutdown. So this is my advice to you. Okay. So this we have discussed already, control logic. Okay. So yeah. So this is a hydraulic circuit diagram for your HPS system. Okay. So you can see here lines P1 line, P2 line. So these are your pumps. Okay, hydraulic pumps, HPS pump 1, 2, 3. Your suction pressure gauges, your accumulators at the discharge site, and then all pumps providing this high pressure oil to this P1 line. And then P1 line is communicating to your P2 line by this Norditon pipes. Okay. This is a generic PID or Parker pumps. if you have to do troubleshooting this, please refer to builder drawings. These are drawings by MAN. Okay, depending upon your engine builder, which can be HHI, Hyundai Heavy Industries. Okay. It can be CSC in China. CRC also have different licenses, whether it is Qingdao or Pudong. Okay. So please consult your engine builder's drawing, because that will be specifically for your vessel. These are what is available in MAN drawings is generic. Okay, they might give Parker or Rexroth pumps, but still it will not be exactly what is available or installed pump. So please, when you are doing troubleshooting or getting yourself familiarized, consult. There is a special manual in your manual books, the soft copies, builder drawings, mechanical and electrical. So refer this mechanical. So here you can see that pumps are pressurizing P1 line, and then P2 line is pressurized by electric pumps. Okay, so P2 line is pressurized by electric pumps. Okay, and then you can see here that this small dotted line is the pilot oil, which is required by your HPS pump for driving. So pilot is a signal coming from your MPC by channel 70, but the operating oil again comes from P2 line, which operates your spool. Signal will come through MPC. The oil will come through your P2 line, and then it will operate the swash plate, and which will ultimately change the angle from positive to negative, and also change the displacement value. Okay, so this you need to understand. Okay, now this is your electric driven pumps. Okay, so these are straightforward electric driven pumps with the non-return valves 305, 306, and then provided to P2 line. And then this P2 line will be isolated from P1 by means of 316. Okay, so you can see here P1, 316. So during testing of this valve, this is 310 valve activating by two coils from ACU1 and ACU3. So activated by two coils. This 316 is normally closed. So if required, you can open it. This is your 311, so 315. So just to give you like to conclude what we understood so far. Okay, so this is your hydraulic circuit diagram for your HCU. Just to highlight that you will have this P2 line coming here. Okay, so P2 line then provided through your isolation valve for SCU 420. So this is in 300 bar system. This will be a hydraulic hose. This will be a hydraulic hose. In 200 bar system, it will go through one SCU to another SCU by a double walled pipe. Okay, so we have discussed today up to here this point. Okay, 420 valve is normally open. Then you have 421, which is a drain, which is normally closed. Okay, remaining is all part of your SCU. Okay, so let's see some field photographs for this one. So this is electric driven pumps. So these are the electric motors. Then you have pumps on inside of this case. Okay, suction valves, and then you have your discharge hoses. And going to where? Going to your safety block. Okay, where is safety block? This is your safety block. So this is the safety block. You will have in the background 3 hydraulic hoses, which is coming from HPS pumps. Then these 2 are coming from your electric pumps, and then you have a drain, and then the third one is for the operation of HPS pumps. Okay. Normally they are covered with a box. Okay. The safety block is normally covered with a. So this is your 300 bar system. So this full railing, this is a common rail, high pressure common rail, and each SCU is provided with this hydraulic hose, which is giving oil to your SCU. So during rounds, you open on the side, or you can, if there is a space available, just put a torch and see that there is no leakages in this type of in this enclosures. Okay. So this is for your supply to SE. Now this is your HPS pumps. So this is HPS pump suction, and then you have pump. You have a controlled oil for the operation of your pump. So on top is your proportionate valve, which is getting signal through MPC, ACU1, depending upon which pump it is. So auxiliary control unit will give signal to this one. And then you have your discharge and high pressure discharge, of course, to this hose, and a accumulator. Okay, accumulator, nitrogen fill accumulator. So in past, we have seen some damages on accumulator. So please do your PMS properly to identify these damages in advance. Okay, so this is your again one of the views of HPS pump. We have minimized to actually see that if your pump is making pressure, but this is more or less it is a part of troubleshoot. Okay. Okay. So let me see if I can share something more. Any doubts, gentlemen, so far? Should we continue?
No, sir.
We should not continue.
We can continue, sir.
Okay. Okay. So, as I said, that depending upon size of vessel, size of engine, you will have different setups of HPS. So most of the cases, we have this type of setup where you have a chain driving the step up here. Okay. As per PMS, you need to tighten this chain. Okay. So I will show you small animation. This animation does not have volume audio. So you can just refer to this what I'm saying. The important point beside seeing this animation is that these sprocket or these chain cases, depending upon engine to engine, whether it is 6 unit, whether it is 7 unit, how much is the bore size, a idle chain case is provided in forward also, which is not driving anything but a movement compensator. Okay. So one will be aft side, which is driving actually the pumps, and one will be forward side, just close to your axial vibration dampers. So both chain cases need to be tightened as per PMS, and both have separate tools. They look same. As you can see here, the bars, the jacks, okay, they are looking same, but their ratings are different, their sizes are different. Okay, this particular hydraulic tool is also different. So when you are using them, or when you are checking inventory as a senior engineer, just make sure that you have isolated forward one from the aft one and keep them separately in a box. Okay, so this is what is required of you. Okay, let's see this smaller animation. Okay, so this is for a bigger in chain, but the concept is same. So you have to tighten the sprocket, Okay, so the sprocket who is giving tightness to this shaft, this will be the free end. So you need to loosen. So this bigger once you don't have to do, just follow what is available in your menu. So normally it is just the installation of these two and then keeping it in position, then releasing A. Okay, so that sprocket is free, and then tightening it to a certain pressure which is mentioned, and then tightening A back. Okay, so not a very complicated issue. Require two hydraulic jacks, one to keep it in a lock position. Okay, then open it, then jack it to a desired pressure, and then you can shift this one. Okay. So this is completed. Remove all the parts. So mind it, when your engine has two chain cases, one is forward, one is astern, so the tools will change accordingly. Okay. So any doubts so far, gentlemen? Doubt, no doubt. So as I said before, we have time to little bit see what is decay test. Okay. So decay test, as I said, is important to see that if our systems, hydraulic systems, the health of hydraulic system. Okay. So here, if you have not used it so far, when next time you go on any engine ship or DF vessel, look for this in your records. Okay, you will find it there. This is a common practice now in the EPS to check the internal hydraulic leakage fault finding. So you have two types of tests here: pressure rise and pressure drop. Okay, so startup pumps 1 and 2 with all cylinder opens. So you have to see that how much time it takes for one pump to develop from 0 to 220. So pressure rise. Then you have to see that from 220 to 110, how much time it takes. That is pressure drop test. Similarly, you have to see for all other units. SU 1 to 11. Okay, so you can keep only one unit open and close other. So I mentioned you before valve number 420. So that valve is used for isolation of other SU units and keeping only one unit active. All other units. Okay, and then once you finish with startup pumps and HU, then it is time for HU. This is little tricky, but I'm sure you will get the point when I mention you that HPS pump 1 you are testing, okay, and 2 and 3 are connected, 1 is not connected. So you remember the fault signal from ACU channel 70 is giving proportionate value, like it is giving proportionate value to your particular pump. Like if ACU1, it will give into HPS1. But we have mentioned this few times that if this signal is missing, if that is fault, so it will go 100% ahead direction. Okay. So if you remove this socket or you remove this signal from ACU channel 70, so this will consider that there is a fault and it will go in 100% ahead direction. In that case, you have to see what is the pressure drop from 220 to 110 with the opening of this valve. Okay, valve number 316 is open. So that way you can see what is the pressure drop. So this will help you identify that the condition of your proportionate. Okay. So this should maintain this should be done as a PMSFT. Okay. Next, I will just give you an insight that if you do it properly, what is the result? So you can see here, SCU number 1, that decay time was 0.44. So 44 seconds it was taking. But when new Parker valve was installed, okay, Rotterdam before change, so much fast decay, and after change 2.5 minutes, 2.5 minutes. So considerable improvement. So here also you can say 0.38, then 3.5, 41, 2.5. So like this, the vessel did troubleshooting, like they maintained this chart, and then accordingly they changed, and all here you can see all of them in seconds, less than one. Okay, less than one, and then all of them close to 2 if they are changed. So like this, if you maintain your checking routine, you can have a better idea about the health of your hydraulic components. Any doubt so far, gentlemen? Gentlemen, Mr. Sampath, you were helping me since morning.
No, sir.
Anybody
No,
else
sir.
who can little bit contribute in this discussion? Any doubt? Okay, so I wish this was a useful session for all those who are first timer on any, and a refresher for all experienced staff who are already working on this one. If any doubt, we are still open for discussion. If something missed out or you have something additional to see, we can discuss as a case study. Okay, so looks like everything is okay. So let's take a 10 minutes break, and then my colleague will take you further in the course. Thank you, and have a safe operations on board.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.
Good morning, good afternoon, good day, everyone. I hope.
Hello, sir.
Hello, gentlemen. Hello. I hope you had a short break, took a coffee or tea, wherever you are. If you are okay, I believe we can continue and finalize the today's topics and the MEC lectures. Are you okay with that? We can continue. I believe.
Yes,
I
sir.
believe you. Okay, perfect. Hello again. My name is Šimon Čota, same as my colleagues from yesterday, Mr. Ante, Smoljo, Ivica, and Mr. Hari. We are coming from the same team, dual fuel technical superintendents. Recently, we have also started with most of the dry dock operations related to dual fuel part. I will be finalizing today's lectures. Mostly my part will cover MEC control system and mostly related to the topics of the PMI sensors or tacho systems. I will be sharing my screen just from your side. If you are okay, we can continue and you will confirm that you have visual from your side. Is it okay? You can see everything. Gentlemen, you can see my presentation. You are okay?
Yes, we can see your presentation.
Perfect. Thank you. Thank you for confirmation. So as I said just before, to close our in-house MEC training, I will be starting with my MEC control system explanations. Anytime if you have any doubt from my lecturers or from the lecturers from my colleagues, let me know. You can interrupt. I don't have any issues with that. So basically, we will start with tacho systems, MPC cards, and Triton system. Triton system, just for your information, has been introduced to the shipping company maybe 2022, 2021, just about things, just about that time when actually MIN, or today I'm not sure if they are called MIN, they are called as Everlens support for our engine. They have introduced Triton based cards to replace the MPC cards with a new engine called MEGA. MEGA is low pressure dual fuel engine. But I know how much you are familiar. They have stopped producing that particular engine due to the several failures, and it was not so reliable to be on the shipping industry or the shipping market. Anyhow, Triton cards were still remaining on the market, but as I know, maybe you can correct me, as I know, for the last few years, none of our vessels which they have supplied, they have Triton based cards. So still at this moment they are producing the engines and they are supplying the engines with MPC cards, which I believe most of us has experience. Even I had experience with the Triton based cards with a low pressure MIN engine. But as I said, at this current moment, I believe none of our vessels has it. I believe just only Coolco LNG carriers, two of them, they have Triton based cards. Okay. As I started my learning objectives, they will be really reasonable for you, that you will understand that you will be able to recognize the various components in the system and able to explain the working principle of the system. So let's start with the tacho system. As you can see on the scene, there are two redundant encoders in our tacho system, encoder A and encoder B. On a MEC engine, tacho system uses redundant angle sensors on the crankshaft 4. So they are located 4 of the engine to measure crank angle, speed, and direction for the engine control. Usually a standard setup has two angle encoders and they are called TSA-A and TSA-B. Plus, you will be having on a flywheel pickup or reference sensor, however you want to call it, for crankshaft angle tracking. What does this sensor do? The angle encoder sends crank position. Based on crank position information, the engine control system will know when to inject the fuel and when to operate our exhaust valve. These are the basic informations you need to understand. These are the trainings given from the MIN for the introduction of the engines. So mostly of you guys, maybe you do have experience with our engines, but we also need to be aware. Usually also we are attending the cadets or even juniors engineers are attending this course. So we need to start from the beginning and to explain the basic information. So even me, for example, I need to refresh myself sometimes. So everybody who is attending the course second time, I believe this will help him to refresh base information related to the MEC engines. So let's continue. As well, there are provided, as you can see, encoder A, encoder B. Most of them are controlled by the ECU A, ECU B. Both of the signals are coming straight away for the monitoring purposes. I believe I have the pictures from one of our MOPs. This one is at least just for the references. It's from the dual fuel engines, but anyhow, an MEC engine will have the same MOP. Just to understand what am I talking about. So all these sensors, which you can see at the bottom, marker master, marker slave, quadrator, that are all coming from the same ECUA and ECUP MPC cards. Quadrator sensors provide speed and rotation direction, while marker sensors, as I mentioned before, marker master A, marker master B, marker master sensors are tracking our crankshaft position. The system itself, it's redundant, so the engine can usually run with one healthy encoder, and in case both of the encoders will fail, you will be having stoppage of our slowdown of our engine. Typical sensor arrangement, I believe it will be like this. I think most of you have seen it. Encoder A, encoder B. They are located at 4 of the engine. Each redundant set commonly includes 4 sensors, so inside them you will find 2 quadrature sensors and 2 marker sensors. The encoders are, as I already mentioned several times, they are mounted on the 4 of the engine, and the pickup sensor is mounted on our flywheel. As we discussed just before, tacho sensors A, tacho sensors B. So these are the signals, as you can see, 4001, 4002A, 4004, up to 4004A. What I mentioned just before, 4001A up to 4004A, it's commonly showed like this. Where to continue? The source itself describes the standard LED angle ranges. So from tacho sensors A will be from 0 to 100, as it is mentioned here, so 0 to 180, and tacho sensors B will be from 45 degrees up to 225. Flywheel pickup sensor will cover up 90 to 270 degrees. Practical meaning, if you are troubleshooting an MEC engine tacho alarms, the main things to check are our encoder alignments. So this will be our base thing before we start any calibration, any software engineering. First thing what we can do from our mechanical side, we'll confirm that alignment of the tacho sensors and our encoders are in good position. Mechanical condition of the mountings, brackets, so we are talking about this part, whether will be both A and B signals agree, or mismatch between these two encoders can trigger also a tacho alignment error and affect cylinder pressure control. Quadrature sensors, for example, as well, and on the MSC engines are pair of incremental sensors. So the tacho angle encoder that can tell the control system how fast the crankshaft is turning and in which direction. They do not give absolute crank angle by themselves. So what they are doing instead, they will shift the pulses which are decoded to track rotation and speed. The two quadrature channels are offset in phase. So what they mean, they are not aligned as well. So the engine control system can see which signal leads the other, and it will, based on that, based on the lead signal, he will determine which engine, how engine is moving. Is it ahead or is it astern? As the encoder disk rotates, the sensor produces pulse, which the decoder will count as and calculate as an RPM, and it will calculate as a movement ahead or astern. On the MEC engine, quadrature sensors are part of each angle encoder, and they are used together with marker reference sensors to build a complete crankshaft position pictures. I believe this is quite sufficient information. Regards to marker sensor, what is highly important for us in case the engine is stands still for a long time, for a period, let's say if we are coming for new building deliveries, or the engine is for some particular reason in dry dock maybe, or we are at anchorage, things like that, we need to do the initial setup of the sensor. So after initial power on, the engine control system will not have the position of the crankshaft. So what we need to do in case we want to start the engine, is it slow turning or by the fuel, it will not start. If we go to the stern, still the issue is there. We need to do one full revolution without turning gear. So based on his recognition of the particular sales of marker master A, marker master B, on all of them, how he will calculate, you will have full revolution and the engine will have positions in order to start the system. Let's say for some particular reason, if channel A leads channel B, system will interpret the shaft rotation in one direction. If B leads to A, it means it's on the opposite. It's on the opposite direction as we understood. So it means the engine is going to astern. I believe it's not so complicated to understand. Engine control system will synchronize the markers and quadrature inputs by using the marker signals as the crankshaft reference point, and the quadrature signals will continuously count the movement between the reference points. In general, if we will speak about the practice part, the engine control system will first locks on the marker position after power up, then uses the quadrature pulse sequence to track the speed, revolution, and direction. Is it astern or ahead? I believe, gents, up to this moment you are quite okay with all the informations. How to understand when your quadrature sensors are reading correctly or not. So based on the last information what we started to discuss, there are this you can understood as our teeth on the shaft which is connected to the quadrature sensors. So basically, sorry. So basically, you have low profile, you have high profile of the readings. Low profile, it means both of the quadrature sensors are reading negative or false signal. How you can understand? If you open your MPC cards on the MOP, it will read as a false signal. So minus will mean false. If your quadrature sensor will be minus and high profile will be reading plus readings, it means you have quadrature sensor 1 false, quadrature sensor 2 is false, and quadrature sensor 1 is positive. So what does it mean in this condition? It means usually as it is set up on all of our MEC engines, it means your engine is turning by a head. In case you have opposite readings, then this one, it means your engine will read. I'm talking about initial readings, so quadrature sensor 1 is positive, quadrature sensor 2 is negative. If you have readings like that, it means your engine is going ahead. In this condition, in case you have plus towards minus from number 2 to number 1, it means your engine is going by a turn. I believe this is quite sufficient information, not to go so much deep. Anyhow, there is not sufficient time in 2 hours. I cannot go so much deep with all this relevant information. Okay, so again, one of the related things for the tacho system angle encoders, how they are set up, marker masters A and B, how they are reading signals. Definitely marker master A, marker master B, 0 to 44, 45 to 90, 90 to 1, 3 to 4, how they are reading the signals. Again, all of this is readable here on our MPC cards. Keep in mind, these informations, the signals are moving and changing very, very fast. You are, I believe, aware. So once when you open the MPC, the information card, you will see that this one is changing quite fast, true, false, true, false. Why? Because it depends on our engine speed. He will change the signal and he will give you the readings based on our engine speed. Tacho system reference sensor, where it is located. I believe most of you have seen it even on board. This will be our amplifier boxes. This is the picture from the beginning of our introduction part. Encoder A, encoder B connection, passing through amplifier boxes, from amplifier boxes going ahead to our engine control system. To troubleshoot engine control system tachometer signal, for example, you have this drifting for some purposes, for some reasons, or you have faults on your MOPs, start by checking the sensor signals. So definitely you will start, as I told you, from the mechanical part. Then you will assist to our electrician, who you will guide him which sensor signals to check, which wiring, and he will assist you also with the mechanical alignment before replacing any part. The most common issues for this part, most common troubleshooting is related to disconnected or maybe damaged cables, poor sensor alignments, I don't know, noisy or weak signals, and mismatch between markers and quadrature inputs. Definitely, you will start with basic check, verify power, grounding, connectors, tacho angle encoder, or secure any corrosion-free cables. You will inspect sensor mountings, basic troubleshootings, and check the air gap alignments. Air gap, of course, between the sensor and the reading part. You will look also for the damaged cables, loose shielding, or any contact that can make signal drift or add certain revolution per minute. I believe we can check also the videos. I have 2 videos which will be quite interesting for you to make an inspection and to make a function test of our tacho sensors. The reference sensors in the tacho systems will be, as we already mentioned, marker master A and B and marker slave A and B. The master sensors will detect the main position on the semicircular region marker ring, and the slave sensor provides a redundant, as we already know, for the engine control system, which will verify our crankshaft position reliably. Marker master A is the primary reference sensor for the system, uses to identify the crankshaft position from the marker ring. Marker master slave is the comparison for the sensor of the system A. He will cross-check the master signal, and he will improve our reliability of the complete system. Same idea will apply to the B system sensor, which form the redundant set for the other control system. Basically, simple explanation will lead us to the think of the master as the main reader and the slave as the verifier. So definitely the master say this is the reference point, while the slave helps confirm, and he will give you, yes, this sensor is giving you the correct readings. I will show you two actually videos which will give you some good points, and I will interrupt it a little bit.
Function test. Maintenance.
I just need from you confirmation. Please give me confirmation you have visual and audios from the computer.
Function test. Maintenance, function test, taco. We select taco.
Gentlemen, you can see everything. You can hear everything.
Yes, sir. Yes, sir.
Perfect. Thank you. So basically, we will start with a function test, with a taco function test, with the turning gear engaged. So we will confirm. This is quite good point. Recently, I have visited one of the vessels to make a technical inspection, and they had some kind of mismatching. I will show you once when the video will start, which will give you the perfect understanding what was the issue.
And you can see that it is split in two tabs in the Triton base. It's split in the churning with the churning gear, and then running the engine and doing these PMI zero diagrams and so on. Okay, let's start with the test turning with the turning gear. Just we need to put in some position the crankshaft. Okay, then we have less steps. It's a little bit more easier compared to the previous software, to the MPC. Okay, for the function test in the MPC based. Okay, good then. As always, we need to be in chief access level, sorry. Chief access level. Okay, we are in chief now.
Keep in mind, gentlemen, who is explaining, this guy who is explaining the tacho calibration, he's doing this on the simulator. So this is not actual condition, but he has the same screens and he has the same engine operation as we have it on the vessel. Only thing he can manipulate with everything, which is much easier, but for your better understanding, it's quite nice and quite nicely explained.
Now preparation, we need an assistant standing and turning wheel. Okay, yes, we have our assistant ready, and we are going to test the taco signals. Okay, then we need to start our test.
So you remember which when I mentioned it on the previous slide, he will now read the signals. You see the tacho marker master A, marker master B, both of them. You need to have the readings true, false, false, false. So marker master A, you need to have reference point. Once when you turn the wheel with the turning gear, you will need to have readings true, false from the marker master A. From the marker master B, you will need to have false, false. At this current moment, his turning wheel, it's incorrect. He will explain you. So what does it mean? If you have the yellow reading here, it means you cannot skip our first step of the test of the tacho signals. So you need to rotate. Once when you have here readings which is same as your reference on the left side, you will have a green go.
And then the first task is to turn engine to 2 degrees after dotted center cylinder number 1. In this simulator, gentlemen, we have a special device. Unfortunately, in the simulator for the exercises, this is not this device, that we can simulate the turning of the crankshaft, okay, with the turning gear. Then we have here, if we go to engine, we can see here the crank angle, and then we have some buttons to operate the turning gear.
So as you can see, his crank angle is now approximately around 356 degrees. If you remember before, the first starting point is he needs to put the crank angle 2 degrees after top dead center. So now he will rotate the engine by the means of turning gear.
Need to put in 2 degrees after top dead center cylinder number 1. Okay, then let's put in 2 degrees. Come on. Okay, a little bit more. Oh, too much. Okay, let's put, oh. 2 degrees. Okay, we go to MOP. You see, now we have put in 2 degrees after total center cylinder number 1. And what means these reference values, gentlemen? This is related taco system A.
So if you remember the screen before, once when you have the yellow reading here, you didn't have permission to press done. So it was completely gray. So you didn't have permission to continue, which means you cannot proceed with your Tahoe function test. Now at the moment, he will explain you as well. He has the proper reading and you have a permission to press the done button, which means you are okay with the next step.
And taco system B. Okay, encoder A and encoder B. And it means the first letter means marker master, marker slave, marker master, and marker slave. Okay, when these marker sensors should be triggered. Okay, then should be triggered only marker master A. You see, true value. Marker master A trigger, marker slave A not trigger, marker master B not trigger, marker slave B not trigger. Okay, true, false, false, false. Then is matching with the reference. Then dark blue background means that we are fulfilling with this. Okay, then we can make we can mark this test as done. Okay. Okay, this is done. This is passed, this test. And now we need to turn the engine 2 degrees after. Go to 358. No. Oh. Okay, 358. We go to MOP. You see, none of these before top the center cylinder number 1, none of the marker sensors should be triggered. False, all of them. False, all of them. Okay, then this test is done. And we need now to turn the engine in a head direction until the test is passing or failing. It is just for triggering all the marker sensors. We need to do a complete revolution just to be sure that all the marker sensors are triggered. We need to do.
So now he will rotate completely the engine, one by one revolution. It's going a little bit slow, as I told you, he's doing on the simulation. Anyhow, it's going slow if we are using on board our turning wheel. So basically, you need to do for a full revolution before he reaches all the certain marks. So we understood, I believe, once the marker master A and B will give you the primary once per revolution reference pulse. That one will define an absolute crank position for that revolution. I think you will remember when I showed you at that certain page where he was reading. I think let me close later on when we stop with we finish this part. I think it's here. You will remember, yeah. So this will be the one marker master A, marker master B, all these signals which are now reading on our simulator. So still, as you can see, he doesn't have passed signal. On the bottom, for example, marker master A, marker master B, this will be slave. So marker master A, marker master B on the bottom. He has a reading with the green numbers, whichever is still written as a T letter. It means still we don't have readings on the particular sensor. So which means, for example, a marker master A will be 0.2, and if we remember from our marker master A will be from 0 to 0.0244. So you have our readings positive. Let's continue with the
When these
I will just skip a little bit, just not to lose the time. He's still rotating the engine.
I think.
So once when we reach,
Okay, thank you.
Okay, you're welcome. Then we have we have done one complete revolution. We go to MOP, and now we have passed the test because you see we have all the marker sensor and turning wheel sensor. These are the reference sensor in the turning wheel, in the flywheel. All of them are triggered and showing the test. Okay.
so after each and every subsequent revolution, the marker master slave and marker master will reset all the absolute reference points, and the engine control system will compare marker timings against the accumulator quadrature count to detect drift or to measure any unusual signal which can affect our engine operation. Once when you press done, it means your
Okay, clear so far, gentlemen?
it means your tacho function set is finished. Once when you finalize with this particular thing, you will do your function test in running condition. So when I mentioned on the beginning before the start of the videos, I visited the vessel which had some issues with two or three sensors. It was a bigger issue. It was a dual fuel engine, but anyhow the issue was not related towards the gas part. It was related to the usual conventional fuel part. We have performed calibration of our tacho sensors. So for the reference point, what did we do? From the beginning, you will see he will open configuration parameters for DSS. Here you will have one information which was completely different than with what we had on our MOP readings. So once when you open this page, it will show you the particular readings which you need to change if it is not the same inside your MOP. He will explain you a little bit deeply, so you'll get the point.
View configuration parameter for the engine control system. View TDC and offset parameter used for commissioning the engine control system. We need.
So just to refresh, this engine now, particularly now, he's doing the function test during engine running conditions. So as you can see, we have, anyhow, I mentioned on the beginning, this is a simulator. So he's now running approximately 60% load, 81 RPM. So
to click on open this, and then the system, it's giving some information about TDC.
So generally, just to keep you aware, this offset ahead he's reading 0.99. This is quite high. Why? Because this is a simulator. Okay, so he doesn't have exact readings. In reality, on our engines, we will have much more less. Okay, it will see the offset will be max 2.2, 0.3, 0.4 as I believe. You will never have this much high. Just for the references, just to explain you, he has a maximum value. Why? Because this is a simulator and he cannot change the data.
Perform at that time, 60% of load, detection of the TDCs, and you see trig A offset ahead, 0.99 degrees. We need to remember this value, gentlemen. This value, I have to say that this is a very high value, because this is a simulator, okay? If you have done the mechanical pre-adjustment correctly, then this offset should be between plus minus 0.25. This is the recommended value, okay? Okay.
Yeah, so just as he's mentioning, the function test we will do after we confirm mechanically everything is okay, which I said on the beginning. So engineers, of course, will check the mechanical part related to tightness of the equipment. Electricians, of course, will check the tightness of the cablings, check that there is no any earth faults or something like this. When you will attempt to make this, if the master and slave disagree, so if you marker master and marker slaves are these are mismatching. So let's say timing difference, missing pulses, wrong polarity, how it will affect? It will affect with higher pressures in the cylinders, later opening of the exhaust valves and things like this. So marker fault and may refuse to use the encoder that will set or switch to the redundant B set. Same as well will be when you will attend the function test. If your quadrature counts doesn't match the expected angle between the markers, the engine control system will report tacho is not aligned and your faults are drifting, which will indicate as a noisy pulses, missing counts, or mechanical slippage from the trigger count.
Then let's remember this 0.99. Let's come back to the MOP again, gentlemen. Go to the maintenance function test. We have performed. Press done when the PMI diagram is finished. Okay, we have finished this diagram. Minimum speed required for valid measurement. 80, we are running on 81.1. It is more than enough. Enter trigger offset ahead and setting the.
Usually on the vessel, this reference point is, if I'm not wrong, will be plus 50 RPM, but either 40 or 50, I'm not so, you don't catch me, I'm not so sure, depends on the vessel. And what I noticed was definitely above 45 RPM. So keep in mind when you are doing function tests in running condition that you are not, of course, doing any maneuverings, any approaching to some things. Do it on the open sea, so you are on the safe side.
ECS parameters. Enter the trig offset ahead. You see this tip? The value should preferably be between minus 0.25 and plus 25, 0.25 if the value is not accepted.
So if you remember the value, so this is the thing where you will insert the offset, which was mentioned at the beginning of the presentation. So in his condition, as this is a simulator, it's 0.99. Reality on board, it will not be more than 0.2, 0.17, 0.15, 0.20, but that will be the maximum thing.
Then abort the test, okay? But we are in the maximum value that the system accepts. But gentlemen, remember that if you are not the trigger offset inside this, please do again the mechanical adjustment, the pre-adjustment, the mechanical part of the encoder, mechanically do this adjustment again because you did something wrong. Because of that, you have too high deviation for the trig offset ahead, okay? Okay, then we need to enter this 0.99, enter. And then you will see tacho alignment deviation, minus 0.99. This tacho alignment deviation, this system use this as a correction. When we press accept, it will go, this tacho alignment deviation, it go to delta tacho V. See here, accept. Delta tacho V, 0.99, and then the system takes this as the correction, as a correction, okay? Okay, clear?
Yeah, I believe this you have now a clear picture regards to the readings and regards to quadrature sensors. Function test, as I mentioned just before, we done it now periodically. You will perform this. Obviously, this is a thing once you have an issue with high pressures inside the cylinders, late opening of the exhaust valves and things like that, means you have lost the proper signals from your sensors on the end. This function test, obviously, you will do once in case you need to change one of the sensors. You have faulty cables, you have faulty sensors, something like that. So every time when you perform a replacement of any of each sensor, you will perform the function test. Stop condition with the turning gear, and in running condition once when you are on safe side, away from the jetty or away from any other maneuvering points. Triton based, as I told you, it's quite similar, but at the moment we don't have it on our fleet. We are using them only on our MEG A engines, which I believe we have only two of them in our Coolco fleet. Calibration as well, same thing. And I think that is quite sufficient. Is it okay, gentlemen? Everything is clear. Everything is clear from your from my side. Okay, it means you are okay. I think it was quite sufficient information. These things are quite related, a lot of related to the controlling system. Maybe you think now it's mostly commonly good informations for our electrical engineers or even the head of departments, but I believe even today all the engineers which are sailing on this type of engine, MEC engine, they need to know at least basic informations. As I told you, me and my colleagues for the last 2 days, we have squeezed this training to 2 days per 4 hours. Usually when you will attempt the Everlands Academy, you will stay for 5 days. In these 5 days, yes, of course, you will be having also the simulators, you will be having some practical things, but generally this is a huge theoretical part. Even though it is just a basic information thing, it is a huge part to be aware of. So generally, I think quite a lot of information. If you are okay, is there any question? Is there any doubts from my lecturing or my colleagues? You are okay with everything? If you are okay, we can go on a break. Refresh yourself a little bit for 10 minutes. Take a coffee, tea, whatever, and we can continue in 10 minutes to close up our MEC, to continue with the last part. You are okay with a coffee break? 10 minutes.
Yes, sir. Okay, we can go.
So, okay.
Thank you very much. Okay, let's go for 10 minutes break. Thank you.
Okay, sir.
Hello, gentlemen. I hope you are back. You are agree with that we continue? You are okay? Gentlemen, you are okay to continue?
Yes,
Yes,
sir.
sir.
Okay, sir.
Perfect. You can see the screen, I believe.
Yeah, it's clear, sir.
Perfect. Thank you, gentlemen. Okay, to finalize our MEC in-house training, we will continue with the last part related to the PMI, ECC on and EMS. Engine management services, EMS or our PMI setup will look something similar to this. AMS-PC related to our alarm monitoring point, alarm monitoring system. MOPB, of course, we will have on board MOPA and MOPB. Why here is mentioned MOPB? Because usual setup by MEC or reference, whoever is on today's part. Our setup is that MOPB will be the master MOP. You will have separately PMI, COCOS, and EDS PC, which is on the side. Apart from that, inside the engine room, this part we are talking about engine control room for the monitoring and operation. Engine room setup will look something like this. Fixed pressure sensors, of course, installed on each and every cylinder on the engine. PMI DAW or data acquisition units inside our cabinets. Junction box, portable measuring unit, which is also connected on each and every unit directly on the engine. System design. Usually our engine will be having PMI sensors, which is provided from only two makers. Not only usually it's only Kistler and ABB. In our scenarios, which I have met on board, is our Kistler sensors. You have two different designs. One is called sandwich design, which is installed between cylinder head and indicator cock, and the second one will be directly on the indicator cock. DAW or data acquisition unit based on FPGA technology, PMI auto tuning application. Again, it will support up to 12 cylinders. When I visit the vessel, mostly we have 11 cylinders, which is on our big container fleet, dual fuel as well. So usually it will support our auto tuning with that kind of engines. Support for ABB and Kistler sensor, which we already mentioned, angle and time trigger data sampling, real-time data logging and transfer, and on unit for the status indication, which is supportive for our engine operation. Previously, I mentioned two different designs. This on the right side, it's sandwich type, so the sensor is installed between the indicator cock and the cylinder head. On the left one, we have different design. We have the indicator cock and the sensor is installed directly on the indicator cock. Sensors, PMI sensors. PMI sensors will help you to read the pressure inside our combustion chamber. So this gives you with respect to the position of the crankshaft with respect to the pressure of your cylinder for each particular unit with respect to the crankshaft angle. So as per MAN BMW service letter, if you read through the service letter, this needs to be calibrated once in the 6 months. Service letter is still coming from the 2019, what I mentioned just before. As you will see, calibration interval from our sensor which are on the engine will be every 12 months or 6 months for the verification. or if we are talking about offline sensor, it's every 12 months. So please keep an eye on it, keep it continuously up to date, and monitor your equipment accordingly. So for the calibration unit, it will be, if you remember, it will be inside one of the blue boxes, which you will take for the later purposes. Remember, crystal sensors are very sensitive to the temperature. They are very sensitive for the high velocity of the gas. So when you mount it on the engine, do not blow through to the indicator cock. If you blow, for example, by the mistake or something, if you blow through the indicator cock, the high temperature and the high velocity can and most probably will damage the sensor, which is a few $1,000s. Let's say maybe it's not even the problem of the price of the sensor. Problem is that you will not find it on the market. So what I'm talking about, usually you will have one or two on board if you are lucky. So take care about them, because as I told, they are expensive. You cannot just go and buy them on the shelves. It's not very easy to get them. So keep a special. Guys, if somebody is using the microphone, can you please switch it off, please? Mr. Villagrecia, have something to say?
No.
Okay, just thanks a lot. Please just switch it off, because it's quite difficult to speak. Okay. Yeah, you need something to say? Okay. So I will start discussion in regards to that when you need to calibrate this particular sensor. So there are only particular times when you will calibrate the sensor. The first time when you need to calibrate the sensor is when you are commissioning on the brand new engine. So it means when the engine will be on the test bed. Usually we are not performing this. This will be done by the maker, correct? The second time when you will calibrate it, when situation will occur, is during running of your engine. Any of these sensors will fail, or you need to replace the particular sensor. Once when you put the new sensor, when you install the new sensor, you will perform again calibration of these sensors. So not only the one, you will do performance test, performance check, function test of all these sensors. So these two scenarios. The third scenario will be there once in every 6 months, which is given by our maker, right? Every 6 months you will verify the sensor that you have proper readings and everything is in order. And I believe there will be one more scenario, the fourth scenario. We need to look at the estimated power on the MOP. So you remember when you open the MOP, you will find that he will give you roughly your percentage of the engine load, right? And you will compare that engine load with a reference point on your COCOS PMI screen. If these two screens are giving you more, the more difference between both of them. So let's say I'm just giving you roughly your engine load, estimated engine load on the MOP is 60%, but your engine load on your PMI screen will show you 62 or 63. So every difference more than 1%, it means you need to perform calibration of these tests, of these sensors. So keep in mind, refresh yourself a little bit once when you come on board, the difference between the MOP and the difference between PMI screen. In case you have readings more than 1%, it means your PMI sensors are not freshly calibrated and you need to perform the calibration procedure. I'm talking about calibration of the online sensors. So we are talking about the sensors which are installed on the engine. When you calibrate these sensors with the offline sensors, which we already mentioned, it is, I believe, here in our service letter. It will look like this. So once when you perform calibration with a offline sensor, that calibration also that sensor, which is called an offline calibration pressure sensor, needs to be calibrated once every 5 years. The difference between our sensor, which is installed on the engine, and the offline sensor called calibration sensor, it's that this sensor every 5 years we need to get a certificate for this one. So either MIN technician will come and calibrate it, or you will send it ashore for the calibration test results, and to receive a certificate that our calibration offline sensor is compatible to use. Anyhow, if you are frequently using our calibration sensor for some period of time, for example, most of your sensors are giving issues, then this calibration should be done more frequently to confirm our sensors are in good condition. The differences between these two sensors will be, as you can see, the lifetime. Kistler sensors are much more durable than the, I apologize, ABB sensors are much more durable than the Kistler sensors. As you can see, 4 years on the Kistler, 10 years on the ABB side. Retail price, mostly Kistler you will find much more faster. Sensor mountings between cylinder cover and indicator cord, which I already mentioned, will be the sandwich type. And ABB sensor, it's clearly visible here, it will be outer end of indicator cock. Sensor technology, piezoelectric based. ABB will be magnetoelastic. Calibration sensitivity, now it's on the ABB side. That's why the ABB will be much more expensive here. Why? Because there is no calibration requirements. Indicator cock valve, reusing existed. Once when you replace the ABB sensor, you need to install new valve as well. Once when you open your EMS or engine management services, PMI display on the top volume, you have the monitor page, key values, you will open and you will have all the PMI readings, which is helping us to monitor our engine more precisely and more correctly, and in case any faults that we can react immediately. PMI on the MEC engine usually refers to, as we know, performance measurement indicator, cylinder pressure measurement, and the tuning system used to monitor combustion and help to optimize our engine performance. On the MIN electronic engine, PMI auto tuning is used for ME engine as well, MEC and MEB, to adjust fuel injection timing and exhaust valve opening for the correct cylinder pressure. In regards to our PMI sensors, it will measure cylinder pressure such as P compress and P max through the fixed pressure transducer on each and every cylinder. PMI itself will reuse that measurements to balance and tune the engine automatically, and as well it will help us to maintain correct combustion, fuel efficiency, for example, and to perform the best load performance to monitor from our side. PMI auto tuning is the relevant PMI version of the MEC engine. It can automatically adjust fuel injection timing and exhaust valve opening to keep the cylinder pressure inside our target value. PMI adaptive cylinder control is described as well, we will see later on, as a successor to the PMI auto tuning, and it's applicable to all PMI MEC engines. What else we can pass by? As we already passed through, the Pmax tuning is done by entering an offset directly inside our pages, inside our MOPs. Let's say if our offset would be minus 1.6, on the left side you can see that PMI compressor tuning is done by entering a compression ratio offset. So compression ratio will be between pressure inside during compressions, P compression and P scavenge. P scavenge is also quite important for us. So these sensors are not working by themselves. They are also using P scavenge pressure to control and to monitor our equipment. What else we can pass through? PMI displays as well. I think this is quite familiar for you guys. You are passing this on a monthly basis to take your performance load programs and to keep your measurements inside your PMS computer. Manual adjustments where you are changing the peak compression or Pmax offsets. Usually you are doing this in the MOP screens. Auto tuning based on estimated engine load, measurement by PMI online, which will give you the current condition, and manual adjusted values, which we are changing the offset on the previous pages. PMI auto tuning. Now we can closely check how he's behaving in normal running condition. So let's say auto tuning will you can compare between auto tuning and adaptive cylinder control. PMI auto tuning is running only in between 45 and 100% of engine load, or above 100% or below 45%. Engine will not perform any auto tuning and it will be in the off condition. Threshold ranges, these are our indication during our running condition, where you can monitor and when you can see how the engine is behaving, how much he's controlling, or how much is your performance of the ejectors, of the exhaust valves, or things like that. Okay, adaptive cylinder control or ACCO. Differences between auto and adaptive cylinder control is PMI auto tuning is activated when you are pressing the button on your MOP screen. On the other side, cylinder adaptive control is continuously running. So any load about 10%, which means immediately if you are going from 0 to that slow ahead or to that slow ahead, it means your engine will be straight away controlled by the ACCO. Load range 10 to 100. Stable fuel index needed for activation. No, ACCO doesn't require these things. Input calorific value of the fuel which is inside our MOP screen, it's not relevant to our ACCO. PMI sensor failure, this is a huge step up from MAN or Everlens, is that even though if you lose one of the sensors, one of the cylinders, it means that our PMI pressure sensors, it means that complete auto tuning will not run. But if our engine is equipped with ACCO, it will not affect with the complete engine operation. It will affect only with one particular cylinder, and engine will continuously control all the operations, and PMI sensors will be on. Differences, if you can see on the bottom, average time of the activation 50%, 98%. Why is this different? Of course, obviously because our load range is much more higher on the auto tuning. Differences between the ACCO or adaptive cylinder control. System overview. Cylinder pressure sensors are sending the signals towards our DAW or PMI data acquisition unit. From data acquisition unit, it's going to our EMS, engine management services MOP. From engine management MOP is going to MOP B, where engine control system will inject or he will adjust ejection or valve timing, and it will straight away control the engine as well. Process adjustment, cylinder pressure process overview. As we mentioned, these threshold icons, this will be definitely in case there is some deviation points where we need to adjust the engine. Everything above these values 3.5 to 6.4 will not be visible as any color changing on our MOP. In case you have more than that, 6.5 or more, the color will be either yellow or red. Is it plus or minus? So everything above 6.5 and below minus 6.5 related to the pressure deviations or related to any deviation inside your cylinder, it will change the color in your MOP screen. For example, it will look something similar to this things. As you can see in this condition, set point of our engine set point of our engine is 100%, but currently our PMI sensor is reading 90 bars. So what does it mean? Everything above 6.5, now currently we have minus of 10 degrees, 10 bars, it will be occurred as yellow paint. It will be measured, it will be pointed out like this. On the other cylinder, we have even more, 120 bars inside the pressure, inside our cylinder, and it will go as a red deviation mark. This screenshot has been taken from a dual fuel engine, but anyhow, just for the explanations, for the reference points, it will be guided to you guys just that you have any relevant information. So what does it mean? The differences between ACCO, how does it work? Engine going to start to stop, engine start, load less than 5%. Still there is no injection, there is no deviation, there is no adaptive running control. Why? Because we said ACCO is running from 10%. But straight away, because he's even recognizing once when you give the kick ahead, the engine is recognizing load is even more than 10%. So he will start straight away on that, even though the load will fall down, he will start with ACCO control. So blue mark means he's already starting. Yellow mark it's freeze. Still there is no any adaptive control. Engine is running, for example. In this condition, they are saying secondary fuel operation node. So it means, as you can see, yellow mark is our fuel adjustment. Fuel adjustment is not relevant at this current condition because we are using just fuel for our pilot. So he's not doing nothing in this current condition. Why? Because it's in yellow. It's frozen. But our secondary fuel, he is doing adaptive cylinder control. So just to make your life easier, forget this one. Let's go on the fourth one. On the fourth step, you can see secondary fuel is yellow. So it means the engine is on fuel operation, normal conventional fuel, and he's not doing any cylinder control. On the other hand, fuel adjustments is on the top part. As you can see, he's performing cylinder control by changing the values, which is relevant to our PMI sensor, and injecting or adjusting our exhaust valve. Load is dropping below 5%. There is no adjustment on each and every load. Is it dual fuel or is it normal conventional fuel? In engine stop condition, there is no adjustment. Everything is in blue and dark blue marks. ACCO, so huge advantage before the huge advantage in front of the auto tuning. It means that, let's say in this condition, we have lost one of the sensors. He's not reading, but all the others are running normally. So our ACCO is running normally for cylinder number 2, 3, 4, and 5, but number 1 we have the error, and the number 1 is not controlled correctly. So what does it mean? We will open under our engine process adjustment. You will change your tuning mode for the cylinder 1 to manual mode, and we will change the value in order to run the engine most effectively. So for example, normal set point for each and every unit will be 40, but in case now we don't have normal operation on that cylinder unit, we will change the value. So pressure rise limiter will drop down to 15, and we will control the engine in this current method, which is most operational and most safer for the running engine. Energy management services. Before we had EMS, we were controlling the PC with COCO CDS engine diagnostic system software, which was installed on the ECR. So all our sensor measurement sensors will go to data acquisition unit. From DAO, it will go straight away to COCOS and EMS. EMS software, PMI auto tuning, COCOS CDS, hardening Windows image, EMS manager. EMS manager uses interfaces for the installation and supervision of the EMS application network, ECS, engine control system, and engine management services, data configuration backup, data exchange services with third party. This is related to our alarm monitoring system. EMS displays and submenus, network EDS PMI. I believe most of you guys have seen it. How does it look like? PMI auto tuning. Later on, I will explain you as well this part related to COCO CDS, how to change, how to add one additional trend if you want to monitor more. Usually they are all installed, but in case you want to add more, it will be explained later on. How recently we have started with our vessels, but for this certain thing we need to be continuously connected to the internet. Through internet, the services which are on the shore side, they will give you sufficient information for your result troubleshooting. So engine controllers, they will send the signals to the MOP. MOPs will, through the firewalls and routers, give you the exact information straight away through the maker on the shore side, and they will assist you in case you need sufficient information for the user troubleshooting. This is a usual setup on our vessels. MOPA, MOPB, and engine management services MOP. On this screen, it's not only installed EMS, it will be PMI, and it will be our COCOS EDS. COCOS EDS, managing basic version. So what does it mean basic version? There is no commissioning needed. It's interface with the MIN or today's surveillance, log and display of data from the main engine control system, and PMI MOP. Why we are using it? For condition monitoring, recording, show trends, reporting, and troubleshooting of the main engine. If you have a full version, and yes, mostly of our newly delivered vessels from the last few years, which since I'm here, most of us, we have a full version, it will include the interface to the other system, alarm monitoring system to log cylinder exhaust gas temperature, BVM for bearing wear monitoring, for liner wear monitoring, the reference measurement for enhanced troubleshooting and performance analysis and diagnostics. Requires only the difference between the basic and the full version. You need to have service technician, but usually this is a normal setup by any MIN technician who is coming on board to install the necessary software versions and to check the system is operational. EMS COCO EDS displays main window. How does it look like? Title bar, menu bar, toolbar. How you can open if you want to see each and every trends. How you can change the colors, same like any monitoring systems. Engine overviews, line recorder and trends. This will be interesting part. How we are using this one. It will record up to 6 hours. Usually on our vessels, it's maximum, I think, 2 hours. How you are extracting? Why? Because if you record for 6 hours, it will be very difficult to send it for the troubleshooting on the shore side. Short trends are stored up to 3 weeks. Major trends stored forever. Long trends stored up to 5 years. Standard reports for the COCO CDS engine diagnostic system. All the values which we are taking for the easier monitoring and to change any of the parameters. This is generally for the reporting side. Once when your PMS system requires on monthly basis to perform any performance test and anything similar to this. I believe this is quite a lot. Is it okay, guys, gentlemen? Everything is covered. I know this is a lot of information, but it will settle down in this or that way. Definitely, you have experience. So I think if anybody is new, if anybody has any doubts, any questions, please let me know. We can pass through. Are you okay, gentlemen? We can continue.
Yes, sir. Continue, sir.
Okay, thank you, guys. Thank you, gentlemen. Okay, this is one of the really interesting thing. Why? Definitely, you will face the issue once when we cannot do too much from our side. What does it mean? If in case we did our thing, we did our part mechanically, we have changed all the spares which we had doubt that they were faulty or that they were not working. We did inspect all the wirings and we have confirmed our part mechanically and electrically has been covered, you can always affect with the scenario that we cannot restart the engine in a most safer way or normal running condition, that we will need assistance from our maker. So I will explain you, guide you to the part how much information they need from us to assist us as much as possible. So how to get troubleshooting data? These are the things which are relevant from the MEC engine. SS scope means this is for the secondary fuel, but just for our reference for the MEC engine, these first 4 points will definitely guide us to assist to the shore-based personnel. Line recorder, which I already mentioned before, do not keep the timings, let's say line recorder from 0 to 6 hours. Why? Because usually hardware and software on the computers for the PMI and for the EDS, they are not so big. And the best option for me, if you decrease the time, what I mentioned before, to 2 hours, which is quite enough for the line recorder to extract the data. If we keep for the 6 hours, the files will be huge to send them ashore. So line recorder, how we will take them. On the system page, you open the database, you find, let's say, for example, we had an issue on 28th of August 2023. You will put your comment. Once when you put the comment, you open it in our line recorder database and you send it towards your hardware inside the computer. Once when you open it, if you can see, this is a huge file, 142 megabytes. So we need to decrease it as much as possible. You zip the file and you prepare it to send it ashore. So the first file will be your engine EDS on the top, and the second one when you install, because this I'm telling you, this is already pre-installed and pre-set up by the technician on board. So once when you open your D drive, inside your D drive you will take your engine EDS file and your line recorder. Why engine EDS? This is because engine EDS file is never changing. This is only for our type of engine, which is directly on board. Once when you open line recorder, you find your file which you have already zipped. Once when you file, these two files are the first one which you need to send ashore. Event log is a little bit simpler. You will open your MOP screen. On the MOP screen, under alarms event log, you insert your USB pen drive, which is on the bottom of your MOP screen. Once when you insert your USB pen drive, you press the export and save it straight away to your P drive. It will take a little bit more time, maybe 1 to 2 minutes. When he extracts it, you will have information USB now saved. Once when you have visual this information, it means you are ready to continue with the next step. The third one will be your engine control system parameter. It's similar to our previous step. You will open on the admin page. It's in the bottom right corner system option. You open the admin page, version. Once when you press the version, on the bottom left corner, you have refresh page. When you refresh the page, all the ID points with the addresses will be in our screen. You inject your USB pen drive and you export it as SPAF to our pen drive. It will take same 1 to 2 minutes. Once when you export it, you remove the USB and your data is saved. The last step for your extracting data for the sending ashore will be HCU event extraction. As well, you open the maintenance page, troubleshooting part. You open HCU event, and for example, here you will find particularly for the cylinder number 5. let's say you have an issue with cylinder number 5. So when you open the troubleshooting page, you select CCU5 because this is the last event which gave you the issues, right? And that's why you cannot run your engine or you cannot perform engine well, because you're suspecting CCU that cylinder number 5 is giving you an issue. So once when you select all the HCU events for the CCU5, you extract it as well, you insert your USB and you extract it to your pen drive. Once when it is saved, you take out the pen drive, and now you have all the relevant data for the shore-based personnel, which can assist them to easier troubleshooting or to assist you with more relevant guidance. I believe this is quite okay for you guys. I believe you understood everything. On the bottom, you can see this is the data, how will it look like. So CCU number 5, burst login. I think I have something similar here. Yeah. So usually this LDE pilot plot you have on your PMI screen. So let's say I have extracted, let's say number 5, CCU number 5, and you open it, you have all the data visual. So FIVA set point, FIVA feedback, FIVA controller, plunger position, exhaust valve position, and tacho angle. So if you can see, dump file can easily guide them where is the issue and how and what to see. You can zoom, unzoom, and to see all the relevant data. So this is the file which you are also sending to your maker. Okay, troubleshooting data finished. CU event we already passed. I think it's really not so much complicated. This guy also we don't need. Okay, this will be your EMS CDS display groups. So in case you want to add or remove any additional COCO trend or rewrite or add additional data to change or so on. Usually all these trends which are on your COCO files will be showing you all the relevant information, but for some purposes they are missing something. So if you want to add more, once when you open your EDS display group in the tools page, you open the launch editor. Once when you open the launch editor, this will be your screen pop-up. Display groups editor, if we want to add new, you open the parameter, you found it in your search page, you opened whichever you need. For example, they are searching for the fuel oil index, you extract it to the procedure display group name. Once when it is in this side, you press the OK. And the trend itself will be on the bottom. The only difference to save your display group, to save your trend, is that you need to restart your EPS. Why? Because this is directly connected to your engine control system. So I'm advising you to do this particular thing once when you are anchored or alongside or engine is in stop condition. Why? Because once when you restart EMS and EDS display groups, it will directly affect to your auto tuning and directly affect to your ACCO. So best option will be once when you are on the anchorage or when you are alongside the engine is in stop condition. Once when you add the additional trend on the bottom of each page, so let's say you had before 77, now you have 78. On the bottom, you can find your trend. And the last thing which we can pass, a bit of user instructions for the main engine. In some of the things, maybe it will be related to SF, but generally it's nicely explained. Inside the system options on the bottom right corner, once when you click it, you need to change the user towards the chief in case you want to change some parameters or not only monitor. If you are only for the monitoring purposes, you keep continuously on the operator level. Prepare start, run auxiliary boiler. What does it mean? Once when you put it in auto, all of these things will be done automatically. Governance mode, there are two modes. RPM is of course focused on keeping RPM. Torque is focusing on keeping fuel index, and it has benefit to keep it at RC as a default mode. As I know, recently even the evidence itself is recommending continuously to keep torque mode, but this is individually, and I cannot give you direct instructions. Usually you are following your technical superintendents, or based on your experience, you will keep as the engine will confirm much more safer and better. Once when you select the governor mode window, it will open on the bottom, governor mode selection, RPM control, torque control, and you select it as you wish. On the bottom top side, if you have control down, for example, this is one of the good things for the engineers. As you know, most of our engines are quite limited with the engine load. So basically, whatever you select, for example, on the top side, you can see, let's say, maximum allowable load on the engine. I'm just giving some figure, 60% or 60 RPMs. Let's say you can insert your 60 RPMs here. Once when you give command on the bridge will, even though if they put 62, 63, 64, 65, they cannot go above 60. Why? Because you can manually set up your value here, and they cannot increase as much as they can. Main starting valve, this is during the running condition, how you can monitor in which condition is your starting valve. If you want to perform from your side the inspection, you can click on the main starting valve. It will open on the bottom, the valve test window. Once when you open it, you can test it and to check that everything is operational from your side. Engine status, HCU status fuel oil. Once when you open, let's say in some condition, it can occur as a fault to that particular cylinder. If you click on the, let's say, first one, doesn't matter what, whichever you click, it will open the window on the bottom, as you can see. If you need to reset, it's not required when it is in normal, but in case you throw an alarm, it will be red. It will set here alarm, and it will open here the set button. Here now you see it's gray. You cannot even press it because obviously engine is operating normally. Manual index offset during this running condition. You want to increase or decrease the mean value for the index calibration. You change the value by clicking and opening the window. On the bottom, it will pop out the window. Speed modifiers, as you know, there are several of them. Start, chief index, chief load, air to fuel ratio, hydraulic press. However is engine behaving, it will show you the information. It will be selection as it is here. Manual offset for the cylinder pressure and for the exhaust valve opening. Fuel oil adjustments. It's already checked just before, once when I explained if you have an alarm. Exhaust valve opening timing. Same scenario in case you have an issue with one of the units, how you can deactivate and activate. Chief limiters, chief maximum load. This obviously any chief engineer who is coming on board, he will adjust the required data as it is given by the maker and following our EPS standards and EPS SMS. Okay, I believe this is quite enough. Most of these informations are given by the makers. So again, same thing related to hydraulic system details, how you will open, driven pump, startup pumps, how you can monitor which continuously is working. If you want to manually operate our hydraulic system, you change the HPS mode from auto to manual, and then based on that you start the pump. On the bottom you can see follow control. Based on, you can change as well these things. Why? Because obviously control pump is assisting the follow-up pump. Usually usually I saw him, I saw our chief engineer as well as me when I was sailing. This is changing. Let's say a monthly basis, you change the control and follow up pump. AGR, cylinder lubrication, nominal feed rates, how we are changing. Running in feed rate will be obviously much more higher than usually. How you are changing, selecting, and adjusting the sufficient lube oil to be inside. Feed rate factor, increase or decrease depends on the condition of the engine, new engine, fuel, sulfur, breakpoints, and minimum feed rate. Pre-lube is there, obviously we know during the off running condition of the engine once we are doing slow turning or checking the engine prior departure or sailing out from our ports. ARCS, CCS system view input output test. So differences a little bit by to test let's say our MPC cards. Simply you can do it by pushing the test button. Once when you push the ECU, for example, a normal mode, once when you open the window, on the bottom it will open normal to test. Once when you change the test mode, all the values will get to the manual mode. When you change it to the normal, it will go to automatic mode and you can continue to run the engine in normal condition. I believe these are quite sufficient information for you guys. I need some kind of feedback. I believe you have. Can I ask you please to switch on your cameras to close our meeting? Gentlemen, please. Hi. Nice to see you.
Hi, sir.
So basically, just to finalize our training, I know this is a lot of information. Anyhow, it will settle down. Most of you, I believe, you have some idea. There is also, I can see some engine cadets here. I know it can be a bit confusing, but once when you come on board, it will settle down. Most of our trainings which we are giving to you are extracted from instruction manuals. So I believe the backup, if you miss some part, you can catch up from the manuals. If you have any doubts now, please let me know. We can speak a little bit. If no, I believe you have sufficient time to understand everything. Thank you for your assistance. I believe Mr. Avinash from the training part, he have put you some training form to fill up. Anyhow, thank you very much. Hope to see you somewhere on the mostly my colleagues and me, we are attending the dual fuel vessels. I hope to see you somewhere on the vessel. Thank you for your assistance. Thank you for your 2 days attendance. I wish you all the best and a trouble-free engine, okay? Thank you very much and enjoy your end of the day. Thank you.
Sir.
Thank you.
Thank you, sirs.
Thank you, sir.
Yeah. Thank you.